So guys, as you people know, in the last day, we have discussed about what is statistics, how the statistics is going to help you being a data scientist or even data analyst, and what are the sections that we are going to apply. And also we have seen what are the different types of statistics we have, and also we have covered about what are the different types of data, like qualitative data, quantitative data. In quantitative, we have seen continuous and discrete. In qualitative, we have seen about nominal data and ordinal data. In the types of statistics, we have gone through the descriptive statistics, which will help you to know more about your business. And also we have learned about the inferential statistics, which will help you to take a decision about the population by looking at the observations in sample. Clear? So see, we are going to see about few data collection techniques. So don't think these are the only one. We have so many also. Just to get an idea about how we are going to collect the data, I'm giving you this. Okay. So what are the different data collection techniques that we have? See, data collection in statistics involves gathering the information to address the research question or the problem. The common methods including the surveys, experiments, and observations. You get my point? See, the way you are going to collect the data have three different ways primarily. One is by the survey, second one is by the experiment, and the third one is by the observations. So each with the strengths and weaknesses. Each have positivities and negativities. Okay. So surveys will collect the data through the questionnaires, while experiments manipulate the variables to observe the effects, and the observations involve the recording the behaviors or events. Okay, whatever the people, data scientists or data analysts, people are mostly going to get the data from the observations itself. When a customer logins, how he is viewing the products, how he is buying the products, what kind of products he's buying. So depending upon that, for example, he's frequently watching about the fashion wear items. So wherever he go, Facebook, Instagram, wherever he go, he'll get the recommendations or the advertisement related to those products only. You get my point? So like that, you're going to get the data. So let's see about the surveys. Let's see about the survey. See, as per the definition of the survey, surveys are the methods of data collection that involves asking the individuals or a group of individuals a series of questions to gather the information. See, for example, I wanted to know about a particular person or a particular thing. So I can directly go and ask a set of questions so that I can get an answer. So those answers might be my data. Okay, or you can go and ask the questions of a group of people. A group of people. See, if this session is coming, right, whenever you go to your regular classes, your faculty will be asking you what is the feedback, how you felt, and what is the session duration, is it practical or not. So these questions will be asked to the group of questions. The responses will be given by the group together. So that is nothing but a grouped way of collecting the data. Okay. So the purpose of collecting the data by using survey. See, the purpose of collecting the data by using survey is they are used to collect quantitative data. For example, numerical answers, demographics, or qualitative data. Examples of collecting the data by using surveys is questionnaires, or polls, user polls. You see, if any serious issue is running on the state or country, all the TV channels will run a poll. If you accept this or if you support this particular person, then say yes. If not, then say no. So like this. Mostly we see this at election time. Okay, so that's what poll and online survey. See, if you people are watching YouTube video, all of a sudden sometimes you'll get an ad survey, skip survey. So those are nothing but online surveys. Even though there are some applications, guys, they'll conduct a job of online survey. They'll give you some set of questions. If you're giving the right answer, then you'll get 5 rupees, 10 rupees, like that. There are the things that are collecting this kind of information. So that's what. Next, advantages of the survey. See, advantages of the survey is survey can be efficient and cost effective for gathering the data from large number of people. See, whatever the data you're going to collect from the survey will be very good data, because you are the person directly going into the person, directly you're meeting him and you're asking the questions, you're collecting the response. Whenever a person giving you the response, you can easily identify whether he is telling you the truth or whether he's lying. Yes or no? So the quality of the data is very good. Okay, so and you can collect the data from large number of people. So that is the advantage. And coming to the disadvantage, the response rate can be very low and bias can be introduced through the question wording or the sampling method. See, I told you that I'll go and ask some set of questions. The question, the way I'm asking the question may change the answer, right? See, I'm politely asking what is your name. Hey, what is your name? See, the tone change means obvious. Instead of giving the answer, simple question only, but it leads to the fight. Okay, so that's what I'm saying. And coming to the survey, if a person has to ask the question without disturbing the relationship between us, then he needs a proper training how to ask the question. Sometimes whenever you go to the villages, if you're going and asking, is it a own house or rented house, how much you're earning, so immediately they'll become violent. Okay, so you're coming from government did nothing for us, see the roads, see the house, why you're asking all these questions, get out of my house, like that they'll behave. So you need a trained person. For training you need money. And whenever you wanted to collect the data by directly going into the person, you need a traveling allowances, staying, food. It's a lot of cost. Okay, waste of time, waste of cost. Those are the disadvantages. Okay, next, the Okay, waste of time, waste of cost. Those are the disadvantages. Okay. Next, the way we are going to collect the data by using experiment. By using experiment. See the definition. Experiments involves manipulating one or more independent variable to observe the effect of dependent variable. I'll give you a simple example. You see, come, please. See, I'll give you one normal example. Regularly we see, as we people know, how the level of advertisement we are doing, obviously the sales will increase. Yes or no? We always believe that whenever you're going to build a new product or whenever you wanted to launch a new product into the market, everybody thinks that if you do the adding, TV ad, Instagram ad, Google ad, then it obviously increases my sales. Yes or no? Here, I'm going to do the experiment. Okay, first month, I'll do the advertisement completely in Instagram. I'll observe whether the sales are increasing or decreasing for day to day. If I'm not able to see any response across the months, let's say I did this for continuously 3 months, no increment or no decrement, it's a stable one. So I'll stop doing the advertisement in Instagram. Let's say I did Google ads. Google ad means if you open a Google, if you open any website, in the frequent website, you will be able to see the ads. I'll observe like this, if it is increasing or not. If it is increasing, I'll spend more in advertisement in Google ads. I'll go by the premium services. If that is not the case, I'll go by YouTube. I'll go by television. You get my point? So I'm doing an experiment. From the experiment, I'm collecting the data. Depending upon the data, I'll take a decision. So this is how you are going to collect the data from experimental methods. Is this clear? Experiment in the sense, that's what. The purpose. They are used to determine a causal relationship between the variables. Basically, whenever you conduct experiment, unknowingly, it will let you know the relationship between the two. See, whenever I see Google ads, if the sales are increasing, if I'm decreasing the Google ads, the sales are decreasing. You got the observation itself. And also you got an insight that if the Google ad increases, this increases. Both have a positive correlation. Positive relation or positive correlation means both are moving in the same direction. Negative correlation or negative relationship means if one is going up, another one goes down. If one is going down, the other one will go up. Don't worry, again we'll discuss about this correlation and regression separately. Clear? So this is our example. Controlled experiments, randomized controlled trials, and the field experiments are the common type of examples for the experiments. See the advantages. Experiments can provide a strong evidence of a causal relationship. Here you're not guessing, you're practically doing the experiment, you're having the practical output, so you can blindly believe the output whatever you're getting. And whatever the decision that you're going to take out of this will be obviously works. So that's what. Disadvantages. Experiments can be time consuming and expensive. Let's say I wanted to do the experiment, guys. So I'm spending $10,000 on Instagram, $10,000 on Facebook ads, $10,000 on Google ads, $10,000 on TV advertisement. Altogether $40,000 I'm spending. But in this, I'll be able to see only the revenue from Google ads. Facebook ads, Instagram, TV, useless. So waste of time, waste of cost or not. Unnecessarily I'm wasting. Yes or no? Whenever you conduct an experiment, you're wasting money. So that is a disadvantage that you have. But usually we do experimental data only because we need a proof. We cannot go by the blind decisions. So that's what. So this is about the way collecting the data using experiments. So the next type is observation. You have to observe. From the observation, you'll get the data. I'll give you the best example. Everybody will observe, guys. Everybody will observe. For example, you recently joined in Naresh IT. Let's say you people are staying in Kukatpalli. Kukatpalli or somewhere else. The session starts at 9 o'clock. Day one, you believe, okay, it's around 10 kilometers. If I start by 1 hour early, I'll reach. So you start by 8 o'clock. Nearest bus stop. You went there, the bus came at 8:20. Next day also you came, bus came at 8:20 only. Third day also bus came at 8:20. What do you believe? So bus usually comes at 8:20. So whenever you wanted to come to the bus stop, you cannot start at 8, you will start at 8:20 exactly. You observed. From that, you took a decision. And see the weather report. Everybody use. See, if you observe the weather, if it seems like raining, you will carry the umbrella. If it is not, you don't. Yes or no? From the observation, you are getting the data. That is nothing but a data collection by using the observations. Clear? See, observations involves systematically watching and recording the behaviors or events in a natural setting or a controlled environment. You are clearly sitting, watching and recording what happening, why it is happening. The way you are collecting the data is known as observations. Clear? The purpose of collecting the data by using observations is they are used to describe the behaviors, patterns and the relationships. If you wanted to identify the patterns, if you wanted to identify the behaviors, then you can go by using observations. You can go by using observations. Okay, so that's what. Even the people also, most of the people in this batch also joined in online, day 1, day 2. But they observed that when we are joining in online, it is not effective. We are not able to connect. So the people started coming to offline. Okay, the observation help you to take a right decision. That's what. Examples. See, direct observation or participant observation and a structured observation like checklists are common types of observations. Okay, so these are the examples. The advantages of this is observations can provide a detailed and rich understanding of the behaviors or events in their natural context. Whenever you sit, you're clearly observing, so it will give you the good understanding about the behavior of a particular person, behavior of a weather, behavior of a business, anything, it will be gives you clear understanding. So that's what disadvantages. Observations can be time consuming. Observations can be time consuming. You need to wait for the reaction. You need to wait for the reaction, then only you'll get an observation. So that is the problem. And other data collection methods that we have in the market is focus groups. Means discussion with a small group of individuals to gather the qualitative data in a specific topic. See, in the market also, in the real-time business also, guys, being a data analyst or being a data scientist, we might be giving you the business insights, but the business person cannot take directly an action. They have a board people, they have a group of people on the board, they'll discuss, then only they'll take a decision. So that is nothing but a focus groups. Even the another way of collecting the data is interviews. Face to face or telephone conversations to gather in-depth information. And secondary data analysis. See, using existing data collected by some other people for your purpose. That is nothing but a secondary data collection. The way we can collect the secondary data is textbooks, publications, or Google, TV, movies. See, have you ever seen God? No. Have you ever seen Sri Krishna looks like this? Nobody knows. The movies conveyed like that from the descriptions of Asian books. So we are believing the God looks like this only. Yes or no? Krishna looks like a bit black. No one's seen that. But the people are saying, so we are always believing that. Yes or no? So that's what. The data collected by someone and we are using that for our purpose. That is nothing but a secondary data collection. There are multiple ways of collecting the secondary data. Clear? So that's right. Simple. Whenever you people join in any organization, you people are going to work with the secondary data only. Because being a fresher, even though experienced with 2 years, you people are not allowed to contact with a direct customer. You people are not allowed to collect the data directly from the user. Clear? So that is about the data collection. So is this clear about the data collection techniques, guys? Even people in online. So could you please share this PPT after the class in the community group? So please speak a little slow. Oh, sorry. Okay. So usually I speak a bit fast. Okay, I'll reduce. Okay, so now we are going to see about descriptive statistics. Anyway, we have gone through the overview. What is this and how it is going to help. Now we'll see in how many ways we are going to collect the descriptive statistics. Okay, see, descriptive statistics involves summarizing and organizing the data, in a way that provides a useful insights and makes it easier to understand. This can be achieved through the measures of central tendency, measures of dispersion, and percentiles and quartiles. These statistics will help you to describe the main features of the data set. Okay, so first we'll go and discuss about the measures of central tendency, then slowly measures of dispersion, then visualization. Okay, yesterday also I already gave you a lot of examples when the college wanted to send a person for a competition. Okay, so like that, central body. So measures of central tendency means it's a measure of central tendency. It describes the central or a typical value in the data set, which will be helping you about the remaining data points. In the measures of central tendency, we'll try to measure a central point, which is a representation of all the remaining data points, or the central tendency is the point where all the remaining data points are surrounded by. Means majority of the values are surrounded to this particular value. For example, I'm talking about the sales. Average sale amount is 2,500. What I mean to say that majority of the sales around this only, 2,500, 2,600, 2,400, 2,450 rupees, 2,520 rupees. Like that, all the sale values will be surrounded by this central point. Clear? So that is what measures of central tendency. So how many ways that we can calculate the central point? Okay, the way you are calculating the central point is known as a average. Can any people tell me that average and mean are same? Average and arithmetic mean are same? Same? Then what about median? No, median is not the average. It's a middle value, pure middle value. Okay, what about mode? Yeah. But you people are wrong. Average and arithmetic mean are not the same. Average is the measure which is used to find the central point. Average is nothing but a central value. Average is nothing but a central tendency value. Calculating the average, we have 3 different ways. You can calculate the average by using arithmetic mean. You can calculate the average by using the median. You can calculate the average by using the mode. You getting my point? Arithmetic mean, average are not same. Arithmetic mean is a part of average. Arithmetic mean is one of the type of average. Median is a one of type of average. Mode is a one of the type of average. These three are averages only. Mean average, median average, mode is also average. But each one have a separate definition. But overall, these three are averages only. Okay, don't say this. So both are equal. Okay. Yes, different methods to calculate the average. Good, good, good. Okay. So in this, first we'll go and discuss about the mean. Yeah, guys, you people already know about that arithmetic mean, how we are going to calculate, even though I'll explain you. Okay. See, mean is the also known as arithmetic mean. The mean is the arithmetic average of set of values. Mean is arithmetic average of set of values. How it will be calculated? It is calculated by summing up all the values in the data set and dividing by the number of values. Dividing by the number of values. You see the formula mean, sum of xi divided by n. Here xi is nothing but observations. x1, x2, x3, x4, x5 like that. So that is nothing but a sum of the observations by number of observations. Okay, for where xi represents each data point and represents the total number of data points. And example, for example, I have observed the quantity of orders. How many orders? How many items a particular person is ordering? See, 4 items, 5 items, 6 items, 7 and 8. What is the mean items? What is the mean number of items that every person is including in their order? How? Sum of the observations by number of observations. So 4 plus 5 plus 6 plus 7 plus 8 divided by 5 is equals to 6. So what is the mean number of items that everybody is adding in their order is 6. Clear? So that's what. And here, whenever you calculate them in their order is 6. Clear? So that's what. And here, whenever you calculate the median mean, you need to remember one important point. That is, the arithmetic mean is sensitive to the outliers, which is very much affected by the outliers. Sir, first of all, what do you mean by outlier? Outlier is nothing but an extreme value. Outlier is a value which is completely different from the remaining data points. Okay, you see, whenever you see in a classroom, there is an extraordinary student. Why the student is known as an extraordinary student? Because when he compared with the remaining students, he got a good knowledge, he got a good IQ, he's getting a high percentage. Yes or no? So that is one. Here, whenever you collect the data, in the data you have extreme values or outliers, then these outliers are going to affect your arithmetic mean. So by keeping this drawback in the mind, we are going to calculate the median. We are going to calculate the median. Let me help you with the real-time example in general, how this mean is going to help take you to the wrong decisions. Okay, so let me open one particular Excel. Let's say, guys, you people completed the course. You got an offer letter from 2 companies, company A, company B. Okay, let's say you say company A. Okay, so whenever you're going to join, you could see that there are 5 employees in the company. Just assume. Okay, so employee salaries. Let's say employee name. Let's say there are employees called ABC, something else, or okay, like this PC. Okay, so the salaries are, let's say 15,000, let's say 20,000, let's say 21,000, and let's say 24,000. There is one fellow highly experienced in the team. He's the one first hired, highly experienced guys, doing the same job. See, whenever you go to the market, most of the people will ask, sir, how much salary I'll get if I join as a fresher? See, your knowledge will decide the salary, not your experience, not your educational degree. The way you're performing in the interview, the freshers will get even 20 lakhs as well. Even the 10 years experienced person may get 5 lakhs per annum also. It completely depends upon the performance. So he might be doing the same job as a data analyst or a data scientist, but the salary of this particular fellow is 80,000. The salary of this particular fellow is 80,000. Let's say 1 lakh. Okay, so this is company A. Next, same way you have another company called company B. So you got the opportunity from the company B as well. So here the salaries are like 30,000, 35,000, 45,000, 40,000, and next 25,000. Like this you have. So usually what we do whenever we get an opportunity means you need to go and do the research about the company. Okay, what is the work-life balance? You go to the Ambitious Box, Glassdoor, LinkedIn, Google, you'll get the review. When you go to the Glassdoor or Ambitious Bucks, they'll give you the average salary that you can expect in this particular company, being a data scientist. So how you calculate, let's say, average salary. So in Excel, to calculate the average, we use a function called average. And in Excel, whenever you wanted to write a function or a formula, the formula or function starts by the equals to operator. Equals to, I wanted to do the average. So you just type AV. Excel is very easy, guys. You don't need to remember any formula. You just know the name of the function. Immediately it will give you the suggestion. See, I remember only AV. So you see, so many options you got. In this, I wanted to go by the average. Select the average. Double click. The average comes into the cell. What is the average? Average of these values, right? So let me select the average of these values. Even though you wanted to calculate, you can do this. 15,000 plus 20,000 plus manually also you can do. But from the childhood onwards, you people are seeing. So directly I'm using formula. So if I accept the offer letter from the company A, then my average salary is 36,000. Okay. Let's say what is the average salary from the company B is equals to average 35,000. What is the average salary? 35,000. So you tell me which company offer letter you people select? Company A. But you people are freshers, right? You people know nothing. You people have no hands-on experience. Yes or no? What happened here? You believe it that if you join in a company A, I'll get a 36,000 rupees as a salary. But here the problem is, because of this particular senior employee, because of this high knowledge person, the salary is went to the 36,000. Let me remove that fellow. Let me remove that fellow. Average after outlier. Then what is that? Is equals to sum of the observations. 15,000 plus, or directly I can do, is equals to average of only these people. I'm not selecting that 1 lakh. I'm not selecting 1 lakh. Let me close it and do it. What is the average salary? 20,000. But coming to the company B, you see any outliers? Everybody equal knowledge, equal experience, somehow related salary. So you took a wrong decision or not? See, if you would have joined in company B, your salary might be 35,000, but you took a wrong decision by joining here. So you accepted the offer letter. Once you accepted the offer letter, what you do? Immediately you put a resignation in the company. So once you put a resignation, you cannot take back. You don't get a respect then. Yes or no? So you have to do the job for 20,000 only. See the effect of outliers, how it is going to impact. Like this, if you keep on talking, there are so many problems with the mean. Clear? So that's what. See, whenever you wanted to find the central point, if there are no outliers, then you can go by using the arithmetic mean. If you could see the outliers, then you have to go by using the median. Okay, let's see what is the median. Arithmetic mean. If you could see to find the central point, if there are no outliers, then you can go by using the arithmetic mean. If you could see the outliers, then you have to go by using the median. Okay, let's see what is the median. The median is nothing but a middle value. Median is nothing but a middle value in the data set when the values are arranged in ascending or descending order. First of all, whenever you wanted to calculate the median, you must organize your data in ascending or descending order. Once you do that, whatever the middle value that you can see, that will be your median value. Whatever the middle value that you have, that is your median. Is this clear? So here also, see, for example, how many 1, 2, 3, 4, 5 I have. So in this, I need to sort my data. So whenever you sort this data, 15,000, 20,000, 21, 24. So what is the middle value? 21,000. So what is your average salary? 21,000. Let's say the X. So what is the middle value? 21,000. So what is your average salary? 21,000. Let's say the extreme value converted from 1 lakh to 2 lakhs. Even though what is your average salary? 21,000. Let's say this fellow salary is 3 lakhs. Even though is it affected? No. So that is the speciality of median. When you could see outliers in the data, then you can go by using median. Clear? This is about when you have odd number of values. When you have odd number of observations, see 1, 2, 3, 4, 5. Sir, what about even number of observations? For example, you have an even number of observations. Let's say like 1, 2, 3, 4. 1, 2, 3, 4. In that case, how you calculate means you need to select the middle 2 points. What are the middle 2 points? These 2 and 3. So now you need to take the arithmetic mean of these 2 points. Then that will be your median. Clear? Clear? So this is how you people are going to calculate the median. See, even though I mentioned, if there is odd number of values, then the median will be your middle value. If there is even numbers, then the median is the average of 2 middle values. See the example of the data set 4, 5, 6, 7, 8. 5 plus 7 divided by 2. That will be your 6. Clear? Key points to remember when you people are working with the median is median is less sensitive to the outliers than the mean. And median will be specifically used with ordinal data and interval of data or ratio data, means continuous data. Okay, so that's what. Next is mode. Next is mode. Mode is nothing but a most frequent value. Mode is nothing but a most frequent value. See, the mode is the value that appears most frequently in the data set. See, mode can be calculated from the numerical data. Mode can be calculated from the categorical data. But in real time, majority of the cases, we use mode when we wanted to see about the most frequent category. You get my point? Whenever you are observing the most frequent value from the categorical column, that is qualitative column, qualitative data. In that case only we use mode. You get my point? See example for the data set 4, 5, 666, 7, 8. So what is the most frequent value? 6. 6 is my mode. In the mode, you have another types also. Unimodal, bimodal. This is unimodal. Means there is only one value that is having highest frequency. What do you mean by bimodal? There is a data like 7, 7, 7. Now 6 have the same frequency highest. 7 also have the same. So bimodal means you have two model values, 6 or 7. You get my point? That is bimodal, trimodal, like many model, multi-modal. So many things you have. But that you people don't need. Knowing the mode is enough. Sir, how this we have seen mean and median, how it is going to affect with this particular salary example. With this particular salary example. Then what about the mode? How the mode will be help you in real time? In real time. Okay. See, I don't want to go much into the technicalities. I'll help you in understanding in a simple example. For example, guys, I'm running a cloth store. Okay, like a cloth store or cloth showroom, whatever it is. In general, in Telangana, Hyderabad and this locality, Dasara is the biggest festival. The people are buying the new clothes in the other festivals or not, I don't know. But for Dasara, definitely all the people in the house will buy the new clothes in Telangana. Okay, in Telangana, there is a habit. When it comes to the AP, when it comes Sankranti, everybody will buy the new clothes. From north side people, Deepavali is the biggest festival. So for Deepavali, they'll definitely buy. You decide whatever the season is. So whenever it comes to the season, I need to maintain the good stock in my shop. So what happened? I have a budget of 10,000 rupees. So I'm going to the market to get the goods. Okay. So let's say I'm running a male store or female store, whatever it is. Now I'm in a dilemma. Should I get XL size shirts more or L size shirts more, M size shirts more or S size shirts more? I don't know. What I'll do from the historical data, I see the customers who comes frequently. I'll see the customers who frequently looking for the size. So from the size, I got to know the mode value is M size. Sometimes you have a bimodal like M size and L size. Okay. So let's say I'm running a male store or female store, whatever it is. Now I'm in a dilemma. Should I get XL size shirts more or L size shirts more, M size shirts more or S size shirts more? I don't know. What I'll do from the historical data, I see the customers who comes frequently. I'll see the customers who frequently looking for the size. So from the size, I got to know the mode value is M size. Sometimes you have a bimodal like M size and L size. So what I'll do, I'll go to the smuggles. In the 10,000 rupees, 8,000 rupees worth of items I'll buy for L size shirts and M size shirts. Few selected shirts for XL, few selected shirts for double XL. I think you people have already observed. You go to any shop, you see double XL shirt. You don't find much variations. You don't find much colors. See M size, L size, so many varieties, so many colors, different variations. Why? Because we have calculated the mode. The L size and M size are our model values. Those are model values. So depending upon the model value, you're taking the decision for the business. You getting my point? Yesterday also I told you, Santurad. From the gender, I calculated the most frequent gender. I got to know that female. Immediately, I gave a lead role into the female actors and the supporting character for the big actor called Mahesh Babu. Clear? So this is how the mode will help you in real time. Clear? See, calculating mode is not the toughest task. This 3 character function that you have, that's all. If you enter a function, you'll get the value. But what you can say about the value is important. Communication is important out of the insights. Clear? That's why I'm explaining you all these things. Okay. So I hope you people are clear with mean, median, mode. When to use mean, when to use median, when to use mode as well. Okay. So we'll teach stats practically every class through Python or Excel. See, we'll go by Python mostly. See, some formulas I'll implement by using Excel itself. Then we'll go by see the same functions in Python. Okay. That's what. So what is the outlier role in the mode? Mode is not at all affected by the outliers. It has nothing to do with the mode outlier. Okay. Mode has nothing to do with the outlier. Okay. Here we are not talking about the size of the value. We are talking about the frequency of the value. How many times the large value is coming is important. How large it is, it doesn't care. Clear? So that is about this. Next. Thank you. Thank you. See, being a statistical fellow, if I'm not giving that examples means it's useless. Okay. See, that's what I'm saying. You people also already know, guys, statistics. You people are already using, but you don't know that is a statistics. That is the only difference. Now I'm helping you people to connect with your real time. That's all. Clear? Next, we are going to see about the measures of dispersion. See, understanding the measures of central tendency, we have struggled. Okay, we learned mean. Okay, struggled, we learned median. Okay, still struggled, we learned more. Why should I learn measures of dispersion then? Why should I learn measures of dispersion then? I'll give you one example. If you're completely going through the measures of central tendency, you're going to take a wrong decision. You're going to take a wrong decision. How? I'll explain it. Let's go to this particular Excel back again. This one. So this is for central tendency. Let me open one more sheet for dispersion. Let's say in your college, there are two classrooms, class A, class B. There is a famous competition running in the market. If you win in that particular competition, your college is going to get a high reputation. Okay, you are in a dilemma. Okay, should I pass this class A people or class B people? Let's say before going to do that, I have conducted 3 tests on class A, class B. Class A, class B. Okay, class A, I said 3 test scores, or let's say 3 students. 3 students, I conducted an exam about one particular percentage. Okay, first person, let's say student A, B, and C. The test score of this fellow is 20, 20, 40, and remaining 60. You got like this? Okay. Coming to the class B, let's say X, Y, Z. Okay. This fellow got around 40 marks, 40 marks, and 20 marks. These are the test scores. So usually what we do, we go by calculating the average. Depending upon the average performance, we'll take a decision. So let's say average performance of class A. How you calculate? Average performance of class A. This is equals to average of this test score. What is the average test score? 33.3%. Okay. Let me go and calculate the average performance of class B. Average performance of class B. How? Same. Average formula. And I'm going to find the average of this. What is this? 33. If you're completely taking the decision by looking at central tendency, what do you say? Class A, class B have same performance. You can send anyone. So I sent class A. But observe the individual data points. In class A, there is only one bright student. Remaining 2 are dull students. See, usually the families will say, if you are doing a friendship with a useless fellow, you will also become useless fellow. Parents will believe that only. My father used to say always this time. If you're going with that fellow, sometime you will become a bad boy. That's it. Okay, that's it. So here one person is a bright fellow. But when they are in a competition, these 2 fellows will say, no, you're wrong, we're right. Everything is gone. You get my point? Coming to class B, there are 2 bright students. Majority is for bright. This fellow keeps silent. He'll be just a participant. He'll do nothing at all. So the winning percentage is very high when you send class B to the competition. So how you are able to see the variations internally, how the data points are variating from the central point or from the expectation. These variations can be explained by the measures of dispersion. Dispersion means variation. How individual data points are variating is explained by the concept called measures of dispersion. Now you people tell me learning measures of dispersion is important or not? Very, very important. Okay, we'll see. Good. So let's see. Measures of dispersion describes the spread or the variability of the data set. Means whatever the data you collect, how it is variating, how it is behaving will be explained by this thing. For example, you're running a business. You see the profit. How do you calculate the profit? Total revenue minus expenses. Okay, sometimes your revenue is less than your expenses. The profit will be negative number. So loss. If you're continuously getting a profit or if you're continuously getting a loss, that variation is also explained by the measures of dispersion called skewness. Where whoever went to the data visualization in Python, positively skewed, negatively skewed. Have you heard about that? See, if a person continuously getting a success is not good for him, getting a continuous failure is also not good for him. So it should be neutral. So how it is behaving also will be explained by the measures of dispersion. We'll see one by one. Okay. So the first metric that we are going to use in measures of dispersion is range. Range is the difference between highest value and lowest value in the data set. Highest value and lowest value in the data set. See, range is equals to maximum minus minimum. Examples 4, 5, 6, 7, 8. The range is 4. See here, we never use range in real time, guys. But we should know such a formula we have. Why we never use means the formula involves maximum minus minimum. Maximum is nothing but a type of outlier. It is highly affected by the outliers. So that's why we never ever use range. We have a drawback in the range. So to cover the drawback, they have introduced one more function called variance. They have introduced one more measures of dispersion, variance. In the name itself, you have variance means variation. See, variance measures how far each data point is from the mean of the data set. Which means, for example, I have observed the last week. I have observed last week sales, last 10 days. From the last 10 days, I could see that average sale amount I can expect, average revenue I expect is 20,000 rupees. Every day, 2,000 rupees, let's say 2,000 rupees. Okay, what happened? I have a strong feeling that tomorrow also I'll get 2,000. Day after tomorrow also I'll get 2,000. So today, whatever I have my savings, I spent everything because I have a feeling that tomorrow I'll get 2,000 rupees. Is it sure that definitely you get 2,000? There might be a chance you get a 1,500. There might be a chance that you get 1,000. So the variance will help you to know the distance, how far the observed values are from the expected value. Expected value is nothing but an arithmetic mean. You are expecting the arithmetic mean 12,000, but you got 1,000, 1,500. How these data points are, how far these data points from the expected value. This will be explained by the concept called variance. You clear? So the formula to calculate the variance is this. See, the formula to calculate the variance is sum of xi minus mu divided by n whole square. Here, mu is the symbol which is used to represent the arithmetic mean, specifically population mean. Mu means population mean, means whenever you collect the average from the entire population, that is population mean. You took a sample out of it. From the sample you are collecting the mean, then it is known as a sample mean, which will be represented by the small x bar. Small x bar. Okay, that's what we see about this particular formula. How we are going to calculate. Okay, I already have created one particular example. I'll show you how we are going to do the calculations here itself. Okay. Okay. See guys, I say I've been observing the data from the 5 days of sales. Sales from the past 5 days. So from this, I wanted to calculate the variance. I wanted to calculate the variance. See, to calculate the variance, to implement this formula, first I need an arithmetic mean. So let me go and calculate the arithmetic mean. So what is the arithmetic mean? Sum of the observations by number of observations. Let's go by average. Average of this particular value. So what is this average saying? On an average, every day you get a sale amount of 2,600 rupees. Clear? Okay. Now I wanted to calculate the arithmetic variance. To calculate the variance, first I need to divide this arithmetic mean from each and every observation. I'll get some value. Then I need to do the squaring. Then I need to do the sum. Then I need to do the divide. First we will do the deviations. First we will find the subtractions. How? X minus arithmetic mean. Here I'm not able to show you xi. That's why I write this. Okay. X minus mu means is equals to sale minus arithmetic mean. 2,000 minus 2,600. Okay. Is equals to 3,000 minus 2,600 is equals to the value in this cell minus the value in this cell is equals to the value in this cell minus the value in this cell. Done. Is equals to the value in this cell minus the value in this cell. Done. Now what I do? I need to do the squaring. X square means x into x. So x minus mu whole square means x minus mu into x minus mu. In programming, we use star as a multiplication operator. So here, this one multiplied again with the same value. The value in B2 multiplied by the value in B2 cell. Do it same way is equals to this one multiplied by again this one is equals to this one multiplied by this one again is equals to this value multiplied by this value again is equals to 500 into 500. So to get the formula, you did see upper body calculations are done. Now I need to get the sum of value divided by n. So what I'm going to do is, so variance is equals to what I'll do, I'll get the sum of this value. First I need to get the sum of this value. How? In Excel we have a formula called sum of these particular values. Sum of these particular values. What is that? 82,000. Sorry, 8,20,000. Here, what is the formula? Sum of xi minus mu whole square divided by number of observations. What is the number of observations? 5. So what is the average sale amount that you can expect? 1,64,000. See guys, arithmetic mean is 2,600. Expected value. How far it is variance means, how the variance is saying that you are expecting 2,600, but there is a chance you might get a sales from 2,600 to 1,64,000. Will it be possible? 2,600 to 3,000. Okay, I believe. 2,600 to 4,000. It's somehow we can trust. 1,64,000. Can we get? No. Why it is like that? Why? Because whenever you are calculating the variance, we are doing the squaring. Whenever you do the square, even the units also get squared. You tell me, centimeter square will become a meter. You get my point? 10 centimeters into 10 centimeters you are doing. 100. Usually it should be 100 centimeters. But here it is becoming 100 meters. See how the units are changing when you do the squaring. That is the problem that we have with the variance. Yes, we have a measure called variance, even though in the variance also we have a drawbacks. In the variance, you have a drawback. Still, you cannot take a decision by looking at the value in variance. So how can I do the variation? To avoid the drawback in the variance, they have introduced one more formula called standard deviation. The one more formula called standard deviation. Clear? See, someone is asking, sir, what does the ranger tell us about the data? So because of the variance, we get to see how much different outlier means. Yes. So can you please explain when the variance is real time? See guys, simple. What I'm saying is, depending upon the observation, I got to know that on an average, I expect 30 lakhs as a revenue. But you cannot blindly believe that 30 lakhs will be coming. You should know some in-out possibilities. So the in-out possibilities will be explained by the measures of dispersion. The measures of dispersion can be variance or standard deviation. But by looking at the example, we got the proof that if you are going through the variance, it's not suggestible. So we are going to go by using the standard deviation. We are going to go by using the standard deviation. Let's see what is the standard deviation and how we are going to calculate the standard deviation. See, standard deviation is introduced to avoid the drawbacks of variance. So it will have the formula related to the variance. How? Standard deviation is nothing but square root of your variance. Simple guys. Variance. Why we are not using variance? It is squaring. It is doubling. If you apply the square root and the root will be cancelled. Whenever you do square root of 5 square and root get cancelled, you get a 5 value. So to avoid the drawback, we introduce the formula by keeping the square. We give a name as a standard deviation. Simple. Okay, don't get confused to remember the formula itself. Standard deviation is the square root of variance. It represents the average amount of deviation from the mean. How average that you can see the variations. What is the formula? See, simple. Square root of variance. Square root of variance. See, go to the example that we have here. So what is the standard deviation? Square root. In Excel, you have a function called sqrt. Even in NumPy also you see the same function sqrt. Pandas, SQL, you go any programming language to find the square root. The function name is sqrt only. Square root of what? 1,64,000. So what it is saying? 404. What do you mean by that? Means whenever you are expecting your sales is 2,600, then standard deviation is saying that you might get 404 sales more or 404 sales less. You getting my point? The standard deviation is saying that there might be a variation. There might be a variation that you might get 404 more or 404 less. I'll relate you this. For example, from the average, I got to know that every day I'll get 20,000 rupees as a revenue. So today I got an emergency. I need to spend 20,000 rupees. So what I'll do, without having a second thought, I'll spend all the 20,000 because I'll get tomorrow. It's a wrong decision. But when I see standard deviation say that 5,000. So what it will say, you might get 15,000 to 25,000. Maximum, okay, minimum 15,000. So when it comes to the emergency, I'll spend only 15,000 rupees. I'll spend only 15,000 because obviously I'll get 15,000 tomorrow. So this is how the standard deviation will help you to do the expectations, which will help you to know the variations from the observation and the expected value. What you are expecting, what you will getting. What should be the variance? That will be explained by the standard deviation. Clear? In real time, whenever you wanted to see the variations or dispersion, we go by using standard deviation only. We don't use much variance. We don't use range much. Is this clear? How we are calculating? Why we are calculating? How to interpret? See, just calculating the value is not enough. You need to communicate out of the value. See, 2,600, I can communicate. I said just now 404. What is this 404? You are expecting 2,600, but there is a chance you may get 400 more, 400 less. Means 2,200 or 3,000. So take the decision wisely. Clear? So this is how you are going to calculate the standard deviation. Is this clear? So people in online, sir, in real time scenario where the variance will be useful. Again and again, I'm telling you the same thing. Variance will help you to know what you're expecting and what you are going to get in actual. Okay, but variance is highly affected by the units. So we don't use much variance in real time. We go by using standard deviation. Don't ask me the same question again. Okay, see, I'm already being patient and clearly I'm explaining you. Even though you people are again asking me means it's not good. You people are not at all concentrating. That's all. Okay. This is the second time or third time I'm giving the same answer. Okay. This is the standard deviation. Next one, you have interquartile range. Another way of calculating the measures of dispersion is interquartile range. This is specifically in being a data scientist or data analyst. We mostly use IQR for identifying the outliers for handling the outliers. To identify the outliers, to handle the outliers. It is very much important to identify the outliers. it is very much important to handle the outliers. This is one of the step in your machine learning life cycle, in your data science project life cycle. So how can you identify? By using IQR. By using IQR, see, how do you identify this is India, this is Pakistan? By looking at the boundaries. This boundary line will decide whether it is India, whether it is Pakistan. Yes or no? Here also, by using interquartile range, we calculate two boundaries, lower bound, upper bound. Any value going above the upper bound, any value going below the lower bound will be treated as a outliers. Either we eliminate the outliers, either we'll cap the outliers. Capping means, for example, I'm calculating ups, either we'll cap the outliers. Capping means, for example, I'm calculating about the age of a customers. Age, upper limit of the age is 39, lower limit is 19. There is a customer with age of 18, then I'll round, I'll cap it to the 19. There is a customer called age 50. Without eliminating the information, I'll cap that 50 age to 39. That is nothing but capping. There are so many ways of doing that. Clear? Let's see. Interquartile range is the difference between the third quartile and the first quartile. For example, I'm talking about yearly sales. What are the sales from the third quartile? What are the sales in first quartile? Difference of that is nothing but a interquartile range. Capping. See, for example, let's say I have a age of customers. Let's say age 22, 25, 26, 36, 39, 45, 48. And okay, 1 second, there is one more person with age 18, and there is a person called 19. So this is the data that I got. So just assume I calculated interquartile range. Just assume I calculated interquartile range. Then I calculated the Q3, Q1. By using that, I find the lower bound, upper bound. Let's say my upper bound is 39, lower bound is 19. So what I'll do means any value that is going above 39 will be replaced by the 39. Where, see, this will be replaced by 39, and this is also will be replaced by 39. Any value that is going below 19 will be replaced by the 19. So this is called capping. Is it clear? So this is how you handle it. Okay, no worries. See, what is the formula for IQR is Q3 minus Q1. Q3 minus Q1. So by using this, you're going to do calculation of this. See, whenever you calculate the outliers, IQR is very less sensitive to the outliers. Or specifically, we use this for identifying the outliers. So I said we will be creating two boundary lines like lower bound and upper bound. So what are the formulas to find the boundaries? See, whenever you wanted to create a boundary, what is the upper bound? What is the lower bound? What is the upper bound and what is the lower bound? I'll show you. Okay, let me open one more presentation file. Just a minute, guys. See, guys, for identifying the outliers, in regular times, we use IQR or Z-score. We'll discuss about these two also. First, we'll cover about IQR, then we'll see about Z-score. Okay, we'll see about Z-score. Z-score is a statistical method itself. So we came into the outlier concept. So we'll see IQR and also we'll see about Z-score together. Okay, see. What is IQR? IQR method is used to identify the outliers as the values that below the lower bound, above the upper bound. What is the lower bound formula? Q1 minus quarter 1 minus 1.5 into IQR. 1.5 into IQR. Upper bound formula Q3 plus 1.5 into IQR. You people don't ask me that, sir, why only 1.5 multiplied by IQR? See, there are some formulas, A plus B whole square. Why not A plus C whole square? Don't ask me that, sir, why only 1 IQR? Upper Q1 minus quarter 1 minus 1.5 into IQR. .5 into IQR. Upper bound formula Q3 plus 1.5 into IQR. You people don't ask me that, sir, why only 1.5 multiplied by IQR? See, there are some formulas, A plus B whole square. Why not A plus C whole square? Why not A minus A divided by B whole square? The people tested, they have gave the formula, they are using the formula. It's a secondary data. If it is a primary, I would have explained you. It's a secondary one, I'm just following it. I'm also not sure why exactly 1.5. Is this clear? So that's what. Here Q1 is nothing but 25th percentile. See, 1 year, 4 quartile is nothing but a value which is used to divide your data into 4 equal parts. Quartile is nothing but a value which is used to divide your data into 4 equal parts. Again, we'll discuss about quartiles, percentiles, and deciles. Just get a overview. Okay. Q1, 25th percentile. Q3, 75th percentile. IQR is equals to Q3 minus Q1. Okay. So this is how you're going to calculate. So how do you calculate the Q1 by using the Python? See, for example, you have a data. In the data column dot, there is a function called quantile. Quantile. In the quantile, you need to specify 0.25. 25 means 25th percentile. 0.75 means 75th percentile. Okay. So I'll show you 1 second. Let me open the Jupyter notebook. I'll have one particular sample data. I'll see. I'll try to observe the outliers in the age. Any questions? Doubt? I already told you guys, give us a 2 to 3 days time. So we finalize the strength, then we create a classroom, then I'll provide you the notes. I'll promise you that you people will get the notes. Okay, clear? I'm not like that. I'll keep all the notes. By just sharing the notes, I don't lose my knowledge. I have so much. Okay, I just wanted to help. See, my way of doing is I always do the presentation file. Even the code, each and everything will be available in presentation. After completing the course, no one will come and ask me that, sir, how can I do this? Everything you have in the presentation file itself. Okay, even in future also, if you're going on the bus, you need to practice. You don't have a laptop, you cannot open Jupyter. Don't worry. Go to the PPT. You see the code, you see the output, you can validate. Like that only I'll create. I'll share it, no worries. Okay. Go to downloads. So let me open a new Python code file. Just we do calculate this one and then we'll close it. Okay. I could sense it. Okay. Will close it. See guys, I already told you I worked as a lecturer. So I know. Yeah, you might be surprised that why I left the job. People are asking only for the interview. Yeah, sorry, important questions, not for the knowledge. That's why I left. Yeah. Students, whenever we start any topic, simply they'll answer, is this important for the exams? Then only they'll listen, or else they'll leave. I got bored. And government colleges, free education. So free is no value. You're getting anything for a free, no value. So that's what. Okay. So how can we do that? To handle the data frame, we need a pandas library. How can we import the library? Import pandas as PD. Everyone is good at this. Huh? So I wanted to import the data. Let's say data is equals to read the CSV, we have a function called pd.read_CSV. You need to copy paste the path. Go here. There is a file. So go here, copy the path. Copy path and go to the Jupyter notebook. You come over here and paste it. Paste it. See, whenever you do paste, you have to change this forward to backward. So to avoid that, we use a Unicode symbol called R. Then you go by doing this. And I wanted to inspect here itself the head. So guys, this is the data that we have in the data. Name, team, number, age, and height. I wanted to see. So here, I want to check the outliers in the age. I wanted to check the outliers in the age. So we are going to use IQR. We are going to use IQR. We are going to use IQR. So to do the IQR, what do we need? We need to calculate Q1. What is the formula? Q1 is equals to data frame and column name dot quantile of 0.25. See guys, same formula, everything I clearly added in the presentation file itself. You see quantile 25. 25 means percentage of 25 only. So same way, I wanted to go by calculating the Q3. So next I need to find Q3. Q3 is equals to what? Same. Data frame and the column for which you wanted to find the quantile, and the name is 75. After that, you need IQR. IQR, how? Q3 minus Q1. See guys, whenever you people are going to write any programming, first you have a blueprint, execution flow, then keep writing the program, then only you will get a success. Directly go by doing means every time you will get a errors only. Let's say first Q1 is equals to data of, what is the column name? Age dot, I'm going to use quantile of 0.25. Okay, so shift enter. So Q1, okay, we'll calculate everything here itself. Q3 is equals to, so I want 75. After that, I'll go by finding the IQR is equals to Q3 minus Q1. Okay, now I'll go print the Q1 is Q1. Same way, I'll go by print what is the Q3, and also I'll go by print IQR Q3 and let's say IQR. So the interquartile range is this. So from this, what I got to know, the Q1 quartile one is 24. Sorry, Q3 is 39. IQR is 6. Not yet done. We need to build lower bound or upper bound. So now we need to find the lower and upper bounds. We need to find the lower and upper bounds. How do you find the lower bound? Lower bound is equals to Q1 minus 1.5 into IQR. See guys, you know how the calculations will be done, BARMAS rule. So put in the bracket 1.5 into IQR. This is lower bound. Same way, I wanted to find the upper bound. How can I find the upper bound? So let's say upper bound is equals to Q1 minus 1.5 into IQR. Sorry, Q3 plus 1.5 into IQR. Do it. After that, let me print the lower uh, bound is this. Same way I wanted to go by doing the print upper bound. So upper bound. Okay. Then say shift enter. See, what is the lower limit of the age? 15. What is the upper limit of the age? 39. By keeping this, let me identify the outliers. Now, let me see the outlier data. How can I see? I wanted to see the records. I wanted to see the records where age is less than 15 and where age is greater than 39. 39. So, what are the conditions? Condition 1 is equals to, from the data, there is a column called age. There is a column called age. This must be less than lower bound. Oh, sorry, I'll go by copy paste. Lower bound. This is the condition 1 which is less than this. Next, condition 2. What is condition 2? Age that must be greater than upper bound. You know, guys, Boolean indexing in pandas. Boolean indexing. These conditions will give you the Boolean output. You give this Boolean output as an input to the entire data frame, then you'll get the values output. How? Now we'll filter. How? Data. It should satisfy either this condition or this one. Any value that is less than lower limit or above the upper limit. So we used to use the logical operator called OR. So condition 1. Whether I wanted to see the data from entire data frame called data. If condition 1 is satisfying or the condition 2 is satisfying. Condition 2 is satisfying. Is this clear? Then say shift enter. There are 3 customers who are behaving like an outlier. Why? See the age 40, 40, 40. There is no customer less than 15 years age. There is a 3 customers who are greater than 40 years age. So these 3 people are outliers. So we need to take care of these people. We'll see. First we see about Z score as well. Then we'll see how to handle these outliers again. Is this clear? So I'll save this document itself, this code. Okay. File and save the notebook. File and rename. So like outliers. Okay. I'll take the classroom link for timing. Okay, I'll join in WhatsApp, then I'll post this in WhatsApp. For time being, I'm saying. Because if you are getting more gap also, we don't reconnect again. Okay. I'll do that. But give me a time. By the afternoon or by the evening, you'll receive the documents. By the afternoon or by the evening, you receive. Clear? So no doubts. Okay. Online people, is everything clear? What does the symbol means? The symbol is related to the OR. Yeah, I'll say. So good morning, guys.
तो फिजिक्स वाला आपके लिए लेके आया है 90
We can discuss have the multiple measurements like measures of central tendency, measures of dispersion, and the data visualization. In the measures of central tendency, we have gone through the mean, median, mode. Intention of the measures of central tendency is finding the central point, which will be a representation of all the data points. So in that we calculate the mean, sum of the observations by the number of observations. But whenever you calculate this arithmetic mean, it is highly affected by the outliers. So whenever you have seen the outliers in your data, then instead of using the mean, we go by using the median to find the central value. Okay, so this mean and median are most frequently used for numerical columns. When you have a categorical column, you wanted to see what is the average value from the categorical. You cannot do sum of the values by number of observations. You cannot do the middle value as well. See, to guide the middle value also, you need to sort the data in ascending or descending. How can you sort the text data? We cannot prioritize the names, right? So in that case, we can go by using mode. We can go by using mode. Mode is nothing but most frequent value. Okay, see, mode is most frequently used for categorical data. Yeah, I'm just revising, guys. So that's why I'm not sharing a screen. Okay, once we start a specific topic, I'll share my screen. Okay. So in that case, we go by using mode. Okay. See, just by looking at the measures of central tendency, if you're taking a decision, then your decision might be wrong. Yesterday also, I told you the example of company offers, company A and company B. So in that case, we have to go by using the measures of dispersion. So in the measures of dispersion, we have gone through the range. Range is a formula calculated by using the maximum value minus minimum value. So in this, you're talking about the maximum value, which is highlighting the outlier itself. So we don't use this much in real time. Next, we have introduced one more dispersion metric, that is variance. Variance is a metric which will help you to let you know what is you're expecting, what you're getting. What is the variation between your expectation and what is going to be get. Okay, this variation can be explained by the formula called variance. What is the formula for variance? Sum of xi minus mu whole square divided by n. Yes or no? But in the formula, we are squaring the values. We are squaring the values. So that's why we are able to see some high numbers in that. Yes or no? We are seeing high numbers. See, we are seeing high numbers. So whenever you do the square, the units are also getting squared. So that's why the variance is not suitable. Sir, if that in that case, why the people are introduced means, see, I'm telling you every time they'll introduce something. WhatsApp also, simple WhatsApp. You have an old version. Starting at that time, you don't have video status, we don't have audio status. Status means whatever the about you write in WhatsApp, right? That is the status. But now, slowly they introduce image, video status. Now you can do the screen sharing. Now you can do the screen recording. See, the way they're introducing, same way, to overcome the drawbacks of variance, they have introduced one more metric called standard deviation. They introduce one more metric called standard deviation. So standard deviation is nothing but whatever the squares you are doing in variance, that square will be removed. How can you cancel the square? When you apply the square root. So you're applying the square root, so the square will be get cancelled. So by looking at the standard deviation, you can see how far the observed values are from the expected value. Here, expected value in the sense average. On an average, you're expecting 2,000 or 30,000 rupees as a revenue or sale amount. From that, how much you got it in return. So that will be explained by the standard deviation. Okay, and then we started learning about the interquartile range, IQR. IQR is a metric of measures of dispersion, but it has a specific purpose of identifying the outliers. Yes or no? Yesterday also I showed you the programming as well. IQR is identified by using the formula Q3 minus Q1. Here Q3 means third quartile, Q1 means first quartile. Being a technical people, we don't need to go in depth of what is Q1 formula, what is Q3 formula. We should know how to calculate those by using the Python or any programming language. That is enough. So yesterday I told you data frame, select the column name, dot quantile is the function which is used to find the quantiles, even though percentiles, even though deciles. For everything we use this only. How means if I wanted to see the 25th percentile, that is nothing but Q1. How I did df of column dot quantile. In that I gave 0.25. 25th percentile, that is nothing but Q1. How I did df of column dot quantile. In that I gave 0.25. In that I gave a concept, sorry, in that I gave an option called 0.25. 0.25 means 25th percentile. When I say 75th percentile, Q3 means 0.75. These are the quantiles. Then what about the percentiles? How do you measure the percentage? 100%, right? Percentile is nothing but a value which is used to divide the data into 100 equal parts. You get my point? Percentile is nothing but a point or a value which is used to divide the data into 100 equal parts. That's why you see 100 parts, 100%. For example, if you wanted to see 45th percentile value, how do you do? Quantile, in the quantile, you need to give an input as 0.45. 0.45. So obviously you'll get it. Then what about the deciles? Decile is a value which is used to divide the data into 10 equal points. D1, D2, D3, D4, D5, and up to D10. Okay, so this is about the measures of dispersion actually. So I just wanted to show you one more technique called Z-score. How the Z-score will help you to identify the outliers. Cleaning the outliers and handling the outliers, I'll give you the document in PPT, but again your faculty will explain in the regular sessions. I just wanted to help you how this statistical method will help you to identify itself. handling and all those things will be explained by your regular faculty. Even though yesterday I already created the Google Classroom. I hope you people got the link. No, don't worry. You will receive an email today itself. You just go and add it. I already uploaded all the document yesterday itself. In that you have a PPT called outliers handling. You go there. First 2 slides will be identifying. Last 2 slides for cleaning, capping, removing, or filling by the mean, median, or mode. You just follow the instructions. You will be able to do this. You don't need someone to give the instructions as well. That much clearly I maintained in the PPT. Is this clear? So today we are targeting about Z-score, and also we are going to see about skewness and kurtosis. Skewness and kurtosis. I'm not able to share a screen for you people on online. Sorry, online you will be see. Offline people, I'll just explain you orally. Okay, until we'll get that cable. Is this clear? Or else, if you have any questions, you can ask me. Any questions that you wanted to ask, you can ask me. So you're taking a decision looking at the 1 day and that to 20 minutes. అర్థం కాదు. ఎప్పుడు మట్టుకు ఆన్లైన్లో జాయిన్ అవుతారా? అంతమంది కంటే కష్టమేమో కదా. ప్రజెంటేషన్ ఫైల్ కావాలి కదా. Yeah. Okay, guys. So we got the back. I got to close this. So guys, as you people know yesterday, why you're getting speaker again? Hello. Yep. We are very sorry, guys. Okay. The method called IQR, how this IQR is going to help you to identify the outliers. So now we'll see about the Z-score. Now we'll see about the Z-score. Okay. Okay. So let me share my presentation file again back. So we are looking into this outlier detection. So yesterday we have gone through this IQR and all the formulas. How we are going to calculate even. Okay. So now we'll see about the Z-score. Z-score is a pure statistical method. See, in statistics, you have so many types of distributions like normal distribution, binomial distribution, and standard normal distribution. Again, we are going to discuss about these distributions. For time being, let's understand Z-score is one of the distribution. Okay. Z-score is nothing but a metric. It's a statistics. So see, Z-score measures how far a value is from the mean in terms of standard deviation. Means how far the expected value is away from the, how far the observed value is from the expected arithmetic mean. That will be explained by again Z-score. To calculate the Z-score, what is the formula? See, what is the formula? X minus mu by sigma. Here X means each and every observation, minus mu means arithmetic mean, divided by, here X means each and every observation, minus mu means arithmetic mean, divided by sigma. Sigma means standard deviation. See guys, if you people wanted to calculate the Z-score manually, you can calculate. If you wanted to calculate the Z score by manually also, you can calculate. How do you calculate? See, yesterday's example, we have seen that. Let me open that Excel file. Descriptive, sorry, measures of central, measures of dispersion. Okay. See, in the last day, we have used one Excel file. In that Excel file, we have calculated the variance and standard deviation. So, you know, is sigma value. Standard deviation is nothing but a sigma. X is a X, you got it. So, mean, you got it. So, how do you calculate the Z score? How do you calculate the Z score? Z score means, what is the formula first of all? Z score is equals to X minus mean divided by standard deviation. So X means X1, X2, X3. For each and every observation, you need to find the Z score. For each and every observation, you need to find the Z score. How? Let's say here, I'm talking about the top one, that is X minus mean. But X minus mean, you already have it. You already have X minus mean, yes or no? So simply, you have to go by X minus mean divided by standard deviation. How? Is equals to X minus mean divided by standard deviation is equals to X minus mean divided by here X minus mu divided by standard deviation is equals to again X divided by this one. Sorry, I'm only pronouncing in a different way. So is equals to X minus mu divided by sigma. Same way, X minus mu by sigma. So this is how you go and calculate the Z score. This is a manual way of calculating. See, to get the Z score for each and every value, for each and every observation, you need to go by X minus mu divided by sigma. X minus mu divided by sigma. Okay. So whenever you do this, you'll get some metrics. So by using this metric, you have some threshold values. You'll have some threshold values. What is the threshold value? See, whenever you calculate the Z score, if the Z score is greater than +3 or less than -3, you getting my point? If the value, the Z score falls in between greater than 3 and less than -3, those are the values identified as a outlier records. Those are identified as a outliers. See here, whenever you see this value is it records, those are identified as a outliers. See here, whenever you see this value, is it greater than 3? No. Is it less than 3? No. See, -2 is greater than -3. So -1 is greater than -3. So is it an outlier? No. Is it an outlier? No. So remaining are also no. So whenever you use Z score, do we have any outliers in this particular data? No. Okay. Do we have any outliers in this? No. So let's go and see the same example that we have seen yesterday. We used one NBA file, new business application file. In that, by using IQR, we have identified the outliers. We could see 3 outliers records. Yes or no? See, I'll open that one again. See, yesterday, when I asked for the program to show me the records, where the records are falling above the upper bound, below the lower bound, I could see 3 people. Okay, let's see, by using the Z score, can we able to identify the outliers or not? Okay, so next we are going to go by using Z score. Z score. See, you people are able to calculate Q1, Q2 directly, but Z score is a statistical metric that is encrypted into one more library, package, or module, whatever you call it. First of all, we need to import that. How can we import? See that every detail I mentioned in this particular document. You have a library called SciPy. SciPy stands for Scientific Python. SciPy stands for Scientific Python. Yeah, I know you people are not getting properly because it is shared by the multiple pieces. Okay, that's why you're not able to see the clarity. Let me zoom out a bit. Now it's okay. Yeah, okay. See guys, there is a library called SciPy. SciPy stands for Scientific Python. In that you have all the scientific calculator related modules. There is a package called SciPy. In the package, there is a module called stats. You people know what is module and what is package? Okay, yeah. So from the package, from the module, we are importing the function called Z score. We're using the function called Z score. So whenever you apply Z score on a column, directly you'll receive a thing. See, here I'm importing that. Next, what I'm doing, by using the Z score function, I'm passing the column for which I wanted to identify the outliers as an input. See, input. Whenever you do this, you'll get a list of values. Those list of values I'm storing as a new column. I'm storing as a new column. See here. First, we need to import the Z score function. How we import this? From SciPy.stats import z-score. Okay, once you import, now we need to calculate the z-score for each record. Each record. See, being a technical people, we call the rows as a records, columns as a fields or dimensions. Being a data science people, you must call the variables as a features or dimensions. The fields into once you import, now we need to calculate the z-score for each record. Each record. See, being a technical people, we call the rows as a records, columns as a fields or dimensions. Being a data science people, you must call the variables as a features or dimensions. You will be learning about the concept called dimensionality reduction. In the data science, dimensionality reduction is one of the phase in your regular project lifecycle. What do you mean by dimensionality reduction? Means you have to eliminate the unnecessary columns, which will create a disturbance for your predictions, which will create a disturbance for your analysis. You get my point? You people learn about PCA, principal component analysis, which is a master of identifying and eliminating the dimensions. You people see in your regular sessions. You clear? So that's what. See here also, for each and every row, I wanted to calculate how I got the z-score. For the z-score function, I wanted to give an input. What is the input? In the data, I have a column called age. So take this as an input and calculate the output. When I do this, see, it is giving me the direct list of values. Yes or no? It is giving me a list of values. I wanted to save these values into one particular column. How? I'll just give this output as an input to data. In that, I'm creating one more column called z-score, which is equals to this. See guys, whenever you give a variable name or column name in Python, don't use any special symbols other than underscore. Okay, this is a basic naming rule in Python. Okay, so whenever you do this, you got this. Let me inspect, cross check how data dot head. You see, the last column we have added is the z-score. Now we need to filter the rows by looking at the condition. What is the condition? Now we'll filter only the outlier records. How? The condition 1. First condition is what? In the data, in the table called data, there is a column called z-score. This value must be greater than 3. Condition 1. And the same way, the second condition is the z-score must be of less than -3. These are the two conditions. Now we'll filter the actual one. How? From the data, condition 1, or this straight line is a logical representation of OR operator. And means and symbol you see in PC. That's what. Yesterday someone asked me that. See, straight line is for OR. Okay. So condition 1 or condition 2. Condition 1 or condition 2. Is this clear? So let me go and do this. Yeah, I'll copy paste. Am I getting any records? No. You people might be surprised, sir. When I used IQR, I'll be able to see the outliers. When I use z-score, I'm not able to see the outliers. Why like that? Why like that? Because the two methods are used for identifying outliers only, but there is a different scenarios. When to use IQR, when to use z-score. There are two different scenarios. When to use IQR, when to use z-score. Okay. I'll give you that scenarios as well. Sorry to disturb you. It's possible to share the Excel sheet so we can use it. I already shared the Excel file yesterday itself. See, whatever the Excel sheet I used here, measures of dispersion, I already shared you. Today I'll save this as a version 2 because today we have added one more column into this, like standard deviation and the z-score, right? Every day, whatever the text file, CSV, whatever I use, I'll upload into the classroom. Don't worry. Clear? You haven't received it because you didn't add an access. I'll make sure that you people receive an email so that you people can add to that particular classroom and you can download the documents. Okay. So let's go to this presentation file again. Summary. When to use what means? See guys, whenever you do the data exploration, in that you will go by seeing at the distribution of the numerical columns. Yes or no? You go by looking at the distribution of the numerical columns. Okay. See guys, I'll tell you one thing. Whenever you see the distribution of a numerical column, if the column is normally distributed, if the data in that column is completely normal, in that case, you can go by using z-score to identify the outliers. You get my point? Whenever in which column you wanted to find the outliers, if that column is normally distributed, then we use z-score. Means there is no variations, everything is looking good. In that case, we go by using z-score. When the data is not normal, the data is abnormal. Okay. All of a sudden we are getting high sales, all of a sudden we are getting less sales. No certain frequency. So in that case, you can go by using IQR. Okay, make sure that. You might be thinking that everybody, see, we have so many options. We use anyone. No, you cannot use like that. Every option has a priority. Depending upon the priority, you have to go by using this. Clear? We know the priority of mean. We know the priority of median. We know the priority of mode. We know the priority of variance. We know the priority of standard deviation. We know the priority of IQR. We know the priority of z-score. See guys, not only this, whenever you people are learning any tool, know the basics. You know how to use, you must know when to use. You clear? So this is how you are going to use this particular thing. Okay, so handling the outliers I already mentioned, but you people will get the same documents in your regular class. Even though we are in all of a sudden we are getting high sales, then we use to identify the outliers. You see the distribution of a numerical column. If the column is normally distributed, if the data in that column is completely normal, in that case you can go by using z-score to identify the outliers. You getting my point? Whenever in which column you wanted to find the outliers, if that column is normally distributed, the column is normally distributed, then we use z-score. Means there is no variations, everything is looking good. In that case, we go by using z-score. When the data is not normal, the data is abnormal. Okay, all of a sudden we are getting high sales, all of a sudden we are getting less sales. No certain frequency. So in that case, you can go by using IQR. Okay, make sure that you might be thinking that everybody handling the outliers I already mentioned. It's not only this, whenever you people are learning any tool, know the basics. You know how to use, you must know when to use. You clear? So this is how you are going to use this particular thing. Okay, so handling the outliers I already mentioned, but you people will get the same documents in your regular class. Even though you people wanted to practice, you can go by practice by looking at this particular. Code. There are three methods. One, removing the outliers. Removing the outliers. How do you remove the outliers? Just change the conditions. Just change the conditions. Which means, see what I'm doing here. Initially, whenever I wanted to see the data where I have pure outliers, what is the condition? The rows where the age is greater than upper limit, lower than lower limit. Those are outliers. Non-outliers means less than upper limit, greater than lower limit. That will be so see data that is greater than lower bound and less than upper bound. Whatever the data I'll get it, I am saving as a new data frame. Data frame with no outliers. That is how you remove. That is how you remove. Or else the another condition that you have is capping or flooring, I said yesterday. Okay, so what you'll do means to do this in the data frame, you have a function called clip. Clip means see when okay, so what that is how you remove. Or else the another condition that you have is data frame with no outliers. That is how you remove. That is how you remove. Or else the another condition that you have is capping or flooring, I said yesterday. Okay, so what you'll do means to do this in the data frame, you have a function called clip. Clip means see whenever you have a package, you add a clips to get out of this particular thing. Same way, you will add two clips, lower clip, upper clip. Any value that is trying to go out of the lower clip will be replaced by the lower clip, means lower value. Any value that is wanted to go above the upper limit, then the clip will make sure that all the above values will be replaced by upper limit value. Okay, so you just try it and you'll be able to see. Or in the very worst cases, we can go by using the mean or median to replace the outlier value. You calculate the mean or median of that particular column. Wherever the outlier value is there, replace by using the automatic mean or median. Is this clear? Or you can go by using the domain knowledge. You're not able to identify anyway. You have to sit with your client, your manager. You need to explain the scenario. Then they'll give you the solution. Okay, let it drop. Or you can go by using mean or median. Or they'll give you some ideas. Okay, so this is how you are going to use outlier detection, IQR, and z-score. Clear? Is this clear, guys? So people in online, is this clear? See, guys, I already showed you the difference. Now it's time for you people to explore, not for my job. Okay, I already gave you two examples to show you the differences. You people have to Google, you people have to research. If I'm on the only one giving all the things, means what do you people do? Sir, give me another example for discrimination means. You people have to do. Okay. Next, we are going to see about the percentiles and quantiles. I already explained you same. Percentiles are the values. See, guys, percentiles are the values that divides the data into 100 equal parts. So the pth percentile is a value which is represented also as a p percentage. So example, for example, you wanted to see the 50th percentile. That is nothing but a 50th percentile means 50%. Half part, half part. So the 50th percentile is also known as median. You get my point? The 50th percentile is also known as a median or also known as a Q2. Q2, quarter 2. Q2 is also the one divides the data into two equal parts. You can say Q2, you can say median, or you can say 50th percentile. Anyway, the same thing. Okay. Next. What about the quartiles? What about the quartiles? Quartiles are the special percentiles that divides the data into four equal parts. Four equal parts. The first quartile is denoted by Q1, that is nothing but 25th percentile. The second quartile is divided by Q2, that is nothing but 50th percentile. The third quartile is divided by Q3, that is nothing but 75th percentile. Fourth percentile is Q4, 100%. You clear? So that is how. And see, where we are going to use these percentiles and quartiles is box plot. You use the box plot to identify the outliers in visualizations. The box plot will give you the 5 key metrics. The box plot will give you the 5 key statistics. One is minimum, one is maximum, one is Q1, Q2, and Q3. You people completed the data visualization by using Matplotlib? Sivan, no? Okay. Few completed. Okay. No worries, we are going to see the data visualization as well. In that I'll explain. Okay. See, the box plot is the graphical representation of identifying the outliers. We have IQR, we have Z-score. These are the technical. When it comes to the visualization, we use box plot. In that box plot, you'll be able to see clearly Q1, Q2, Q3. So that's what I'm highlighting. Okay. The IQR is based on the quartiles and the measures. So when you wanted to find IQR, there also we use quartiles. Where we use specifically the percentiles and quartiles in real time means identifying the outliers. In identifying the outliers. Is this clear? Okay. See guys, even though I have one more document for the example of mean, median, mode and getting the insights out of it. First we'll complete the theory, then we'll go by the official practical session kind of. Okay. Next, in the measures of dispersion, there are two more metrics called skewness and kurtosis. Skewness and kurtosis. These two metrics are specifically used to see the shape of your distribution. Shape of your distribution. Okay. See, by using mean, median, mode, you are able to find the average expected value. By using standard deviation, you will be able to see what is the difference or distance between expected arithmetic mean than the actual value that you got. Then by using a shape of your distribution, whenever you plot your data, if you wanted to check whether the data is normally distributed or not, whether the data is normally distributed or not, how you can say that? See, for example, if you draw a distribution plot, if the distribution is perfectly a bell-shaped curve, means, for example, the central point is nothing but what? Arithmetic mean, average. So I wanted to see the remaining data points are equally distributed towards right side of the mean, towards left side of the mean. Right side means above the expected value. Left side means below the expected value. For example, I have 5 days of sales. Average sale is 2000. Okay, 2000. I said 5 days. So the middle day is 2000. Central point. So the next day, 2500. The next day, 3000. 2 points towards right side, positive. See, let's say 2500 and 3000. Okay, so this is 2500 and this is 3000. Okay, just assume. And this is what? 2000. This is the central point. So 2 points distributed toward right side and the few 2 days are distributed toward left side. This is 15,000. This is 10,000. Which means the data is equally distributed toward right side and left side of your central point. You get my point? Then in that case, you say the data is normally distributed. The data is normally distributed. For example, you're drawing one more thing. Let's say you're drawing one more chart. You're drawing one more chart. So whenever you do, for example, you're getting like this. Your central point is this. Your central point is this. Let's say positive value 1, 2, 3, 4, 5. And the below values 1, 2. Now you see, is the distribution equal? Is the distribution normal, equally distributed? No. So it is abnormal. But in the abnormal, you have a specific names like positively skewed or negatively skewed. How the data is spread toward left side and right side of your central value is explained by the concept called skewness. Clear? Is the distribution normal, equally distributed? No. So it is abnormal. But in the abnormal, you have a specific names like positively skewed or negatively skewed. How the data is spread toward left side and right side of your central value is explained by the concept called skewness. Clear? See, skew skewness is a measure of asymmetry. Asymmetry means when the data is normally distributed, you have another name called the data is symmetrically distributed. Normal distribution, or you can say the data is symmetric in nature or symmetrically distributed. Whenever you say abnormal, asymmetric, symmetric, normal, abnormal, asymmetric. Okay. See. Skewness is a measure which is used to measure the asymmetry of the distribution. It tells us the extent to which the data is not symmetrical around the mean. Means how far the data are spread towards left side and right side from the central point will be explained by the skewness. Okay, don't worry, those images I already have in this PPT. See, like this. So I'll explain you those. Okay, so that one. Skewness helps us to understand the concentration of the data points around the mean. Around the mean. So when you say the data is normally distributed, when you say the data is symmetrical, means whenever you calculate the skewness value, if the skewness value is 0, if the skewness value is 0, then in that case, you can go by saying that the data is symmetric in nature and normal. Okay. Irrespective of this, we have one particular measure. By using that metric, we'll identify whether the data is normal, positively skewed, or negatively skewed. We'll see what is this. See, the theoretical formula to calculate the skewness is the Pearson's second skewness coefficient. Not only this, you have so many metrics, but this will be easy for being a non-technical, being a non-statistical person to calculate the skewness. Why? The formula see 3 of mean minus median divided by standard deviation. See the formula 3 minus mean minus median divided by standard deviation. We know how to calculate mean. We know how to calculate median. We know how to calculate standard deviation. Substituting, is that a problem? Substituting, is that a problem? No. So by substituting this, you can easily find the skewness value. You get my point? This is the way you are going to find the skewness value. Okay. And see, whenever you get the skewness value from the output, depending upon the given number, you will decide what type of skewness you have. So basically, there are 3 types of skewness. We'll see what are those. The types of skewness. There are 3 types of skewness. That is positive skewness, negative skewness, and zero skewness. Let's start from the one by one. Okay. First, we'll go by zero skewness. Zero skewness or normal distribution or symmetrical. Any name you can give it. When do you say the data is having zero skewness? When do you say the data is normally distributed? Means whenever the data is zero skewness, then the symmetric distribution values evenly centered around the mean, means central point. Whenever you calculate the distribution, the data is distributed equally towards right side, equally towards left side from the central point, that is mean. In that case, you can say the data is normally distributed or symmetrical or no skewness. Or one more metric is whatever the column you have, for that column, calculate the mean, calculate the median, calculate the mode. Mean, median, mode, all the 3 metrics are giving the same output. You get my point? You calculated mean, you calculated median, you calculated the mode. all the values are giving you the same output, then the data is known as a zero skewness, symmetric in nature, normal distribution. Multiple ways you have, guys. Either you can go by finding skewness, symmetric in nature, normal distribution. Multiple ways you have, guys. Either you can go by finding skewness, but being a statistical people, we prefer the easiest one is we calculate mean, median, mode. We see all the values are equal or not. If equal, then we'll decide the data is normally distributed. Sometimes being a data scientist, even if it is looking approximately normal also, we'll consider that as a normal distribution. Okay, so either you can go by using mean, median, mode, or by using the graphical representation called kernel density estimator plot. Kernel density estimator plot will give you the output like this. If the shape is looking like this, then normal. If the shape is looking completely abnormal, then it is a abnormal. Okay, multiple ways to identify, guys. Okay, now, next, what about positive skewness or right skewed? You say this as a positive skewness or rightly skewed or right skewed. When you say this, whenever you say the data is positively skewed, the data is right skewed, means you are going to have the longer tail towards the right side and a shorter tail towards the left side. In that case, you say the data is positively skewed or right skewed, abnormal, anything you can say. And another way of identifying is you go and calculate mean, median, mode. You go and calculate mean, median, mode. As you people know, in this chart, as we are going to a right side, the values are increasing or decreasing? Increasing. Right side positivity, 10, 20, 30, increasing. So if mode is here, mean is here, median is here, mean is here, which means you calculate the mean. Mean is greater than median. You calculate mean, median, mode. If mean is greater than median, mean and median both are greater than mode. In that case, you can decide the data is positively skewed. You getting my point? You getting my point? So you go and calculate mean, median, and mode. Mean, median, mode. If mean is greater than median, mean, median, these two are greater than mode, then you can say this as a positively skewed distribution. Or if you look at the shape, see, you are having the longer tail towards the right side. So you can simply say that it's a skewed data, that too right skewed data. Is this clear? Same way, we have one more metric, that is negative skewness. Negative skewness or left skewed Whenever you say negatively skewed or negatively skewed or left skewed, means or left skewed. Whenever you say negatively skewed or negatively skewed or left skewed, means whenever you see the shape of your distribution, if you are having a longer tail toward left side and shorter tail toward right side, then you say that the data is negatively skewed or left skewed. Or you see, whenever you're going left side, the values are increasing or decreasing? Decreasing. So whenever you calculate mean, median, and mode, if your mean is less than median and mean, median, these two are less than mode, then you say the data is negatively skewed or left skewed. Negatively skewed or left skewed. Okay. I hope you people know how to calculate mean, median, mode out of the data. So by looking at the values, you people can easily decide. This is the easiest way, guys, to decide whether the data is skewed or not. Instead of this particular formula, the easiest way to identify whether the data is skewed or not is by calculating the mean, median, mode and do the comparison. Is this clear? So this is about the skewness. Then another metric that you have is kurtosis. Another metric that you have is kurtosis. Okay. See, skewness and kurtosis both will help you to know the shape of your distribution. The kurtosis will help you to know how the data is spread from the left side and right side of your central point. The kurtosis will let you know the peakedness of your distribution. See, whenever you draw the distribution like this, the kurtosis will let you know what is the height of your distribution, what is the peakedness of your distribution. See, this is the central value. Then how high the central value is, or simply we say kurtosis is a metric which is used to find the peakedness or height of your distribution. You see how big height or the small height of the distribution or the average height of the distribution. This will be explained by the metric called kurtosis. We'll see what is that. Kurtosis, see. While skewness focus on the spread, that is tails of a normal distribution, then kurtosis will focus more on the height of the distribution or height of the shape. Okay, it tells us how peak or flat our normal distribution. The data is normal, but the normal is very high or a low normal. Okay, so that will be explained by the concept called kurtosis. Okay, so how do you calculate the kurtosis? There are multiple formulas. One of the formula for calculating the kurtosis is mu4 divided by sigma to the power of 4. Here mu4 means higher order moment. Mu means higher order moment. See, being a non-statistical person, to understand the higher order means is not at all possible. Higher order moments is not that easy. So I gave you the simplest formula again. You see this? Is not that easy. So I gave the persons to understand the higher order means is not at all possible. Higher order moments is not that easy. So I gave you the simplest formula again. You see this? See, what is the formula for calculating the kurtosis is 1 by n into summation of xi minus x bar all to the power of 4. Here we know x bar, we know xi each and every value. Then do this divided by 1 by n into summation of xi minus x bar whole square and whole power. This is nothing but a kurtosis value. This is nothing but a kurtosis value. So by using this formula, you go by finding the kurtosis value. See, whenever you see the kurtosis, you get a number. If the number is exactly 3, then you say one type of kurtosis. If the output of this particular metric is more than 3, greater than 3, then it is known as one type of kurtosis. If it is less than 3, then it is known as one type of kurtosis. What is this? We'll see. See, the high kurtosis. If the kurtosis value is very high, which means the sharp peakedness, means you have a very large peakedness in the distribution. Okay. Whenever you see the kurtosis value is very less, that is less than 3. In that say, you got very flat surface, not much height, very small height. So depending upon that, the kurtosis is divided into 3 types. One is mesokurtic, One is leptokurtic, one is platykurtic. The shortcut to remember is lamp. Look at the spelling lamp. First L comes, next M comes, next P comes. Next P comes, which means whenever you calculate the kurtosis value, if the kurtosis value is greater than 3, which is greater than 3, then you say this as a leptokurtic. You getting my point? If the kurtosis value is greater than 3 or greater than 0, then you say this as a leptokurtic, means high peakedness, sharp peakedness. Next, whenever you calculate the kurtosis value, the kurtosis value is less than 3, the kurtosis value is less than 3 or less than 0, that is negative number, then you say that your data is having platykurtic. The data is having platykurtic. Okay, so leptokurtic, platykurtic. What is meso? If kurtosis equals to 3 or equals to 0, equals to 3 or equals to 0. You get my point? If the kurtosis value is equals to 3 or is equals to 0, then you say the data is having a mesokurtic. Why I gave you the lamp means you see this particular thing, you will understand. You see leptokurtic means the kurtosis value is greater than 3, high peakedness, like this. Next, if the kurtosis leptokurtic means I gave you the lamp means you see this particular thing, you will understand. You see leptokurtic means the kurtosis value is greater than 3, high peakedness, like this. Next, if the kurtosis value is equals to 3 or equals to 0, equals to 0 or equals to 3, then you say as a mesokurtic. See how normal it is looking. Platykurtic means the kurtosis value is less than 0 or less than 3. See the peakedness. So like this. See here also. High peakedness, leptokurtic. 0 peakedness means normal, then mesokurtic. Very less than platykurtic. Lamp, leptokurtic, mesokurtic, and platykurtic. This is how we are going to use a skewness and kurtosis matrix to identify whether the data is positively skewed, negatively skewed, leptokurtic, mesokurtic, or platykurtic. Clear? So guys, I just wanted to give you one business scenario type question. How we are going to calculate this mean, median, mode? How can we do the interpretation out of this skewness and kurtosis? Okay. See, here we are going to use the Python programming language. So I'm using very short data to address the problem. See, the problem is an e-commerce company wants to understand the customer purchase behavior. Okay, there is an e-commerce company. In the e-commerce company, they wanted to understand the customer purchase behavior. How can I identify? See, purchase behavior to decide the pricing strategies, to identify typical customer spendings and to detect the outliers, means VIP customers. See, usually all the people are spending 1,000, 2,000, 3,000 in my shop, but there are customers who are spending 10,000, 20,000 in my shop, means VIP customers. See, it's not easy to eliminate the outliers every time. It is not suggestible to eliminate the outliers every time. You should know the domain knowledge. Depending upon the domain, you need to go by handle. In my e-commerce business, if the people are purchasing more, outliers means VIP customers. I'm not going to do elimination. I go by treating those people separately. I'll take those people separately. I create a separate customer service team to address those problems. So to do so, I need to identify who are my VIP customers. How can I do that? Outlier detection. How can you detect outliers? IQR. Okay, so that's what. Next, improve the marketing and inventory planning. To address all these problems, we are going to see the descriptive statistics. Clear? See, the data is available is order value. We have a column called order value. So depending upon that, we are going to see all these problems. See, we have the data order value in terms of rupees of a customers in 1 month. In 1 month. See, first of all, let's create a sample data by using Python. How? Import pandas as PD, import numpy as np. See, first of all, I'm creating a list. By using a list, you can create a data frame. By using a list, you can create a data frame. How? Let's go here. So here we are going to address the business problem. Okay, here we are going to address the business problem. So let me create a sample data first. Let me create a sample data. Okay, so what is the sample data, guys? First, import numpy as np and import pandas as pd. And let me create a list of order value, that is order underscore values is equals to what are the values? 4,999. Next, 799. Next, 999. 1499. Next, 1,999. Next, 2,499. Next, 2,399. And next, 3,499. Next, 399. Next, 599. Next value, 899. Next, 1,299. Next, 1,799. And next, 2,299. And the next cell is 4,999. Next, 6,999. 6,999. And next, 4 nines. After that, 299, 399, 499, and 1599, 1899, and 2199. Is this clear? So this is how you have created the list of values. This is how you created a list of values. How can we create a data frame by using a list? See, now we'll create a data frame. How? df is equals to pd dot. To create a data frame, you have a function called data frame. Capital DATA FRAME. Frame. In this, I'm going to use a dictionary. The name of a column is what? Order value. Order value. For this, I'm passing the list of values as a input. Order value. When I do this, let me show you the df. Sorry. Clear? So now let's go and see. See, this is the data that I have. This is the data that I have. This is the order value that I received in a particular month. Let's say 22 days or 23 days. Okay. So this is the data. Okay. We have created a sample data. Now we'll go and see the measures of central tendency. By using the measures of central tendency, what questions can be answered is, what is the typical order value? Means what is the most frequent order value, or what is the expected order value amount? How you can find? By using the mean. How do you calculate the mean? See, you select the column on which you wanted to find the average. Dot. You have an aggregated function called mean. So you apply, you get the value. See, what question we are asking? Okay, what is a typical order value? We wanted to address this particular problem. So we are going to use mean. How you can calculate the mean? Mean underscore value is equals to, you select the data frame. In the data frame, for which column you wanted to find? Order value. Copy this. Copy and paste it over here. On top of it, you apply the function called mean. Whenever you do this, you get a mean value. Then let me print the typical order value given by mean is what? Mean value is mean value. So what is the value? 2,216 means on an average every day. By looking at the 22 days of observation, I can say that you can blindly believe that every day you might be getting around 2,216 rupees as a order value amount on an average. You might get more, you might get less again. You might get more, you might get less again. Okay. So this is how you calculate the mean. Okay. See, what is the interpretation that you can get it? The mean shows. So this is how you calculate the mean. You might get more, you might get less again. You might get more, you might get less again. Okay. So this is how you calculate the mean. You might get more, you might get less again. You might get more, you might get. The mean shows the overall average revenue per each order. This is influenced high by the, sorry, it is influenced heavily by the very high orders. So business insight is, if the mean is very high, then the marketing team might assume the customers are spending more. See, irrespective of the problems, irrespective of the weather, whatever it is, the average order amount is very high, which means what the management team can decide, the customers are spending more. So depending upon that, you can take a decision. But this can be a misleading if only few customers are spending more, but all the remaining persons are spending very less. You getting my point? So that's what. So note, mean is sensitive to the extreme values. So we go by calculating the median. That is nothing but middle value. How you calculate? Same. There are already predefined functions on the pandas. So we go by using that. Okay. So let me go here. Now we go by address the same question by using the second metric, that is median. How? Let's say median value is equals to, let me copy and paste over here. So in place of mean, I need to go by using the median. Okay. So whenever I do calculate like this, so I wanted to get the median value. So what is the median value? The median value is 1599, means 1599. See, whenever you see mean, what you got? 2260, because that might be a problem of outliers. See, observe all the people: 499, 799, 1400, 1900, 2000, 3000. Okay, but look at these two people: 7000. See, approximately 10,000. This might be a problem of outliers, right? Due to some rich people or due to some outlier people, VIP customers, you are believing that everybody is also ready to spend. No, if you have 100% customers, only 10% of the people are able to buy more. So don't take a wrong decision. Don't expect more from your business. Okay, so that's what. You're clear how the mean and median is going to help you? Let's see the interpretation out of this. Interpretation. See, median is nothing but a middle customer, not affected by the extremely high values or low values. So the business insight, the median will tell us what most customers will actually spend without outlier effect. Actually, how much they're spending? 1600 rupees. So depending upon that, you can plan your expenses. Depending upon that, you can do the marketing. So that's what. Better metric for pricing decisions. See, I got to know that the people are willing to buy the items at high price. So the item price is very high. See guys, you see Android mobile and Apple mobile. If you compare the features, Android mobile have a lot of features comparing to the iPhone. But the price of iPhone is very high than the Android. Why? Because they know the people who wanted to use iPhone, they're ready to spend more amount. That's why they're giving high price. They know the quality. They know the features. Even though they're giving high price, even though people are falling to buy iPhone. Why? Because they know the strategy. That's why the price is very high. You get my point? See, the people are ready to buy the iPhone just by changing the color. See, iPhone 7, iPhone 8. 7 blue color, 8 yellow color. That's all. People will die to buy that. They don't add any features. Let's go to the Android phone. I gave you so many features. I'll increase 10,000 rupees. No one will buy that. What is this? For this useless phone, I need to spend 20,000, 30,000. Yes or no? Like that only. So depending upon the demand, we'll increase the price. So by calculating the median, you can go and take a better decision for the pricing strategies. Clear? So that's what. Next, mode. Mode is nothing but most frequent value. So mode value is equals to mode. How do you calculate? By applying the mode function. Let's go here and calculate. So the third metric that we can go by address this particular problem is by mode. Mode value is equals to, go by copying this thing and let me go and paste it over here. So in place of median, we go by using mode. Here we go by using mode value. Here we can go by using mode underscore value. See guys, the problem with the mode is, for example, let me go and print here. Whenever you do calculate mean median mode, you will be able to get the single metric directly as an output. Whenever you do calculate mean median, you'll get the value directly. Okay, but when it comes to the mode, mode is a function which will give you the output of. Okay, before going to see that, you people know the pandas library. What are the two different data structures used by pandas? First of all, what are data structures? List, tuple, dictionary, set. Array is also one of the data structure. Series is also one of the data structure. Pandas is also one of the data structure. So the pandas uses NumPy uses only one data structure, array. You cannot work with any other things. Pandas work with only two data structures. One is series, one is data frame. You tell me, is it a series or data frame? Data structures. One is series, one is data frame. You tell me, is it a series or data frame? Data frame. How many of you say it's a data frame? Hey, question. If I ask the question, people will say series. If I say raise your hand, means nobody says nothing. First of all, what is the difference between series and data frame? Series is a one-dimensional labeled array. Means you have a label in only one dimension. That is row label. See, 0th row and first indexed row. When you say data frame, you have a two-dimensional labeled array. Means you have a row label, column label like this. You have a row label, column label. Do you have a column name here? No, it's a series. It's a series. You clear? So whenever you do calculate, you'll get the output like this. So if you wanted to see the value, then you have to go by using like this. Mode series. From the series, how can you access the values by using indexes? 0 index. When you say what is the mode value? 399. What is the mode value? 399. But in our case, we have two model values by model. One is 399, one is 499. Means majority of the people are buying the items worth of 399 and 499 more. So whenever you wanted to sell more items with a low quality, then have a price as 399, 499. You can easily attract the people. You see guys, Amazon Great Indian Sales. Great Indian Sale offer starts from 299. You go in that, nothing will be available at 299. 599, 699, 799, like that only you have. But how they are pricing in the market? 299, 399. Everything for 299, everything for 399 because of this. If you people see that number, they are interested to see. Okay, so like this. Clear? So this is how we are going to use. So in this, if you wanted to see the mode value, you can go by using 0 or 1, whatever it is. I go by using 0. So what is my mode? 399. Clear? So go to the document back again. See, mode shows the most common order value. What is the business insights? This is useful for creating a combo offers. Combo offers are choosing a popular pricing point. Popular pricing point. You get my point? So like this. Clear? How this mean, median, and mode are going to help you in real-time business strategy. See, we have seen theoretical, we have seen overall practical like pen and paper example. Now we are into the business problem by using the technical tool. Clear? Mean, median, mode. Next, what about the measures of dispersion? What about the measures of dispersion? See, what is the question that you can answer by looking at the dispersion? Means how spread out our customer order value. I expected 1,599, but how the people are varying? Is my expectation same or not? Is my expectations are meeting up to the point or not? Will be explained by this thing. How do you calculate the variance? Simple. There is a function called VAR, a short form of variance. When you calculate, you get the variance. Okay. Next, we are going to use measures of dispersion. By using this, what is the question that we are addressing? How spread the customers are. How spread the customers are. So how you calculate? The variance is equals to, in your data frame, select the column name that is order value. On top of it, you apply the function called var. The same function you have in NumPy, same function you have in Pandas, same function even you see in Excel, same function you see even in SQL. Now see. What I wanted to see is the variation in the order value. In the order value is given by, what is this? It's a variance output. Let me put this. So what is this variance is saying about? See, the variance is very large. How much? 5 lakhs or 45 lakhs, 36,959. Where is 1500 rupees? Where is this 54 lakhs? Okay, so that's why. Measures of dispersion. How? See, this variance measures how far the value spread from the mean. Unity squared. Unity squared. So hard to interpret directly to the business person. You cannot communicate anything to the stakeholder. So business insights in general. If you are getting high variance value, means the customers behave very differently. You're expecting, but the people will behave completely different from your expectations. So suggest need for customer segmentation. Means you able to see the people are varying a lot. So you need to go by create the groups. Low-end groups, middle-age groups, or high-end groups. Okay, the people buying the low-end items, middle items, high-cost items. So like that you can segregate for each and everything. Do the separate marketing, give the separate offers, give the separate discounts. You getting my point? Like this. See guys, whenever you buy any item, an item worth of 1,000 rupees, you get a discount around 10 rupees or 20 rupees. When you're buying a washing machine worth of 50,000, you get a cashback of 2,000 or 3,000. Why? Because of the segmentation. Because of the price segment. Clear? So this is how. So to overcome that, we go by calculating the standard deviation. How do you calculate the standard deviation? You have a function called STD. STD stands for standard deviation. STD stands for standard deviation. Any programming languages, mostly the function name like this one, STD. Clear? So let's see. So here we address the problem by using the first technique, that is variance. Now we go by address the same problem by using standard deviation. How? Let me copy this paste again here itself. So instead of variance, I go by using STD. Here it's a standard deviation. So the variance of the order value is given by ST. So what is the standard deviation is saying? 2,331. 2,331. See, interpretation, how you communicate out of this means average deviation from the mean. Average deviation from the mean, same unit. Means if you are getting high standard deviation, that is equals to unpredictable spendings. Means you are getting standard deviation very high. Usually how you measure means standard deviation from 0 to upper value. If the standard deviation is 0, means 0 values more, 0 values less. Means exactly what you got. If the standard deviation is equals to 200, average is 2,000. Means you get 2,200 or 2,000 less. That is 1,800. Yes or no? So if the standard deviation value is increasing or more, then what you do? You are not able to predict the spendings of your customers. Means it's not that easy to predict more. Then what you do? You are not able to. Yes or no? So if the standard deviation value is increasing or more, then what you do? you are not able to predict the spendings of your customers. Means it's not that easy to predict how the people are going to spend their amount. If you get a standard deviation very less, then it will be easy to predict, and you can take the decision by looking at the central value. Getting my point? So that's low standard deviation means consistent customer behavior. You are expecting these people will buy the items of 500 rupees. Yes, the statement is true. The people are already started buying the worth of items 500 ND. See, the Indian people, we always vote for the discounts. Yes or no? So we go by looking at the discounts. We don't go by the quality, nothing at all. If it is giving you a discount, we'll be forming a line. Yes or no? And you see the price 799, 399, 499. Why can't they put this as a 350 or why can't they put as a 3000? You see that 299. So how much you pay? 300. So you might be thinking that you're giving 1 rupee. Only 1 rupee, right? Okay. How many of you in this particular classroom? Online and offline 300 rupees. If you all the people are taking a course given by me for 299, how much I got the revenue? Extra 3000 or 300 rupees. Like that for Amazon, how many customers are buying for every hour, every minute? How much they are charging? For you, it's a 1 rupee. For the people, it's a crore. There are some business from the direct income. Instead of the direct income, they'll get more revenue from this 1 rupee only. It's a business strategy. Okay. So like this we use. Next, we are already running out of time. So tomorrow we see about IQR and the remaining things, and also we'll go and see the probability basics tomorrow. Okay. After that, we'll see the inferential statistics. Okay. Okay, guys, and thank you. Sure, guys. I'll upload these documents into the classroom. Thank you. Yeah, classroom link will be shared by the admin people, guys. People in online, good morning. Yeah, we are very sorry. A small issue. That's why we started late. So no worries. And also we are going to shift the room from tomorrow onwards. Yeah, good morning. So let me share my screen. Yeah, good morning. So let me share my screen. So is my screen visible to you guys? Yeah. Sorry, yesterday also we faced some issue. So today I was continuing the same. That's why we delayed. So I'll make sure from tomorrow onwards, sharp 10, 9, 10 we'll start the session. Okay. Yeah. So guys, as you people know, so yesterday we started looking into the case study problems. Like we have gone through the theoretical part all the way. So we have gone through the implementation of same kurtosis, mean, median mode by using a Python. Okay. So till yesterday we have gone through the methods of dispersion, like how to calculate the variance and how to calculate the standard deviation itself. So today we see about interquartile range. See, already we have completed IQR by using a particular example, and I already uploaded the sample file and the code file as well in the classroom. Okay. And next, the one more metric that we use regularly is mean absolute deviation also, MAD. Okay, mean absolute deviation. See, you have so many metrics. Almost all the insights are already given by that mean, median, mode, variance, and standard deviation, even kurtosis. See, as per normal general scenario, we don't need much of MAD. So we'll go to the skewness. So as we know, skewness is used to find the shape of your distribution, whether the data is spread across the right side of the mean or left side of the mean. And when it comes to the kurtosis is specifically used to find the height of your distribution or the peakness of your distribution. Okay, so how can we calculate the skewness? See guys, understanding the theoretical part, manual calculation is the toughest task. When it comes to the programming, it's a small function, it will directly gives you the output. Okay, so how you select a column, you have a function called SKEU, skew. By applying this function, you can find the skewness from a Python programming language. Okay, next we are looking for a shape of a distribution. We are looking for shape of distribution. So here skewness. Okay, so how we have a data frame called data. Just now I reopened this one, so I lost all the data. That's why I'm rerunning again. So in the data, we have a column called what? Order value. Select the order value, copy paste, and on top of it, you wanted to apply the function called skew. So whatever the output you get, that you wanted to save into the particular variable called skewness. So after that, let me print what is the skewness. Let me print what is the skewness. See, whenever you do calculate, oh sorry, it's a DF, right? Name of your data frame is DF. By mistake, I used data. See, what is the skewness you got? 2.21. So how can you identify what type of distribution it is having by looking at this particular number? Go to the document again back. See, if your skewness value is positive output, you get my point? Whenever you calculate the skewness, the output given by the function is a positive number. Then it is having a positive skewness. See, long tail towards the right side. If you are getting a skewness is negative value, then you say long tail towards the left side or negative skew. If the skewness value is exactly 0, means no skewness. The data is perfectly distributed as a normal. The both tails are equally distributed to the left side and right side of your arithmetic mean. Is this clear? So this is how you're going to interpret. See, whenever in our example, we got what type of skewness? Positive skewness. Yes or no? So from this, what you can give a business insight? Your data is right skew data because a few VIP customers are available. Okay. Which one? Okay, so whenever you do this, when you have a positive skewness, in the sense positive means more towards positive, higher numbers. So you can think that you have few VIP customers. You have few VIP customers. How can I come across high VIP customers? When the skewness, see here 2.1. For example, your skewness value is around 50, 30. Like that, you can decide the higher number of people are VIP customers. Okay, so if you have a VIP customers, then you have to create a separate plans for VIP customers. For example, regular people will have one type of customer support. Whenever you call to the customer team, they'll put you on hold, right? Our customer executives are busy. Can you please hold for a few minutes? But when it comes to the VIPs, if they calls, they don't need to press 1, 2, 3. Directly, they can contact with a query team. So like that, we can plan. So this is why we need to identify whether we have VIP customers or not. Is this clear? So the next, we are going to find the kurtosis. How to find the kurtosis? We have a formula called kurtosis. Directly apply it and you'll get it. Let's see here. So the kurtosis. How can I do this? Same. Kurtosis equals to, in the data frame, there is a column called order value. There is a column called order value. On top of it, I'm applying the function called kurtosis and then close it. And let me print what is the value that I'm getting as a output. See, what is the kurtosis value? 5.28. If you people remember, when we calculate the kurtosis, if the kurtosis value is greater than 3, if the kurtosis value is greater than 3, then what I said? Mesokurtic or leptokurtic? Lamp I said. First L, which is greater than 3. M, medium, means 0. Leptokurtic, lowest one. Okay, sorry. Lamp, leptokurtic, mesokurtic, platykurtic. Here we got more than 3, means it's a leptokurtic. If you get this value as a 0 or exactly 3, 0 or exactly 3, then you say this as a mesokurtic. If your kurtosis value is less than 3 or less than 0, then you say that is as a mesokurtic. Clear? See. 0 means it's a leptokurtic. If you get this value as a 0 or exactly 3, 0 or exactly 3, then you say this as a mesokurtic. If your kurtosis value is less than 3 or less than 0, then you say that is as a mesokurtic. Clear? See. This kurtosis will help you to identify the measures also, outliers also. And also, whenever you have a high kurtosis, means you have a peakedness, means highest point, or the maximum value is very large. In that case also, you can identify that we are going to have some outliers. But generally, what we use means IQR, Z-score, or box plot. These three are more than enough to identify the outliers. Just by looking at the kurtosis, we just take only one statement, that is, if you are having high kurtosis value, which is more than 3, that to very large number, then fraud risk of or VIP concentration. Means there is a high chance of risk, whatever that you are going to take a decision. Okay, and also you are going to have a VIP concentration a lot. Okay, so that's what you can see. And whenever you have a low kurtosis value, then you can decide a stable spending pattern. Means the people are spending very low and that too stable. Stable means, for example, today I'm spending 1,000 rupees. Tomorrow I'm spending 10,000 rupees. Day after tomorrow I'm spending 1 lakh. Is my spending stable? No. Yes or no? No. So, for example, today I'm spending 1,500. tomorrow I'm spending 2,000. Day after tomorrow I'm spending 18,000. Means my spendings are stable. If my spendings are stable, means I can expect only the lower level. I cannot expect more. Yes or no? If my spendings are not stable, what my business person will think? Okay, day 1 he spent 1,000. Day 2, 10,000. Day 3, 1 lakh. Then day 4, 10 lakhs he can expect. So it's a misleading, yes or no? So that is the problem that you can identify by using kurtosis. Is this clear? So now, how can we go and calculate percentiles, deciles? Already we know, guys, when we working with the, what we say, IQR, we used data frame name, column name, dot quantile function. In the quantile, you need to mention what percentage that you want, what quantile you want. Yes or no? Here also, I have an order value. From the order value, I wanted to find the quantiles. How many quantiles I want? 0.1 means 10%, 0.25 means 25%, 0.5 means 50%, and 0.9 means 90%. For timing, I'll go by calculate the 90%. Okay, let's see here. We are talking about percentiles and deciles. See guys, whenever you say, for example, let's go here. See, when I said, if you're having a high kurtosis, means high peakedness. High peakedness means, how you see the peakedness here, right? How you see the peakedness here, right? So the center point is what? Arithmetic mean. Arithmetic mean, as we know, as the outliers are increasing, the arithmetic mean value will get increased. If you are able to see, it's a vice versa. It's a vice versa. If you are able to see the arithmetic value very huge, then you can suspect that there are outliers. When I said leptokurtic, high peakedness means high central value. High central value means there is a chance of outliers. So that is the way you can conclude that there is a possibility of outliers. So immediately you have to go by using IQR or Z-score to cross check. If you identify, you can eliminate. If you are not getting, then you can be free. Okay, you don't need to do anything. Okay, so that is how you have to take. Is this clear, Balaji? So now we are going to calculate percentile. See, I said I wanted to get the 90%. See, how can I do that? DF. Select the column that you wanted to calculate. Okay. Dot. I wanted to find the quantile. In the quantile, I wanted to find 90%. So 0.90 or 0.9 is enough. 0.9. Okay. When I do, I get the 90% of the data. For example, percentile is equals to this, and I wanted to print the percentile value. How much you got? 4,699. Sir, what is this is talking about? What we find, 90% of the people, means majority of the people are 90%, are like a VIP customers, are spending around how much? 4,699 rupees as their regular spendings. So that's what I mentioned here. See, whenever you calculate the percentile, for example, you calculated 95%, means the top 10% of the customers are spending how much? You get my point? 90% means top 10. 80% means top 20. You get my point? Look at the numbers, how I'm communicating. If I'm talking about 90 percentile, then top 10 customers. If I'm calculating 80%, means top 80%. If I'm calculating 75 percentile, means top 25% of the people. Here, what we got? When I calculated 90 percentile, I got the value as 4,699. Means all my top 10 customers are on an average. All my top customers are on an average. They are spending about 4,699. You get my point? So why we need to calculate this means whenever you wanted to prioritize the customers. Let's say your total revenue from all the customers. Let's say you have 10 customers. You have 10 customers. From all the 10 customers together, you are getting 1 lakh rupees as a revenue. 1 lakh rupees as a revenue. Whenever you went and calculated the 90 percentile out of it, you got to know that the top 10% of the people are spending around 70,000. How much I said? 1 lakh. How much I said? 1 lakh revenue. In that 1 lakh, by using the percentile, I got to know that the top 10% of the people are giving 70% of the contribution. Top 10 means out of 100 people, let's say 100 people, top 10 means 10 customers. 10 customers alone giving you the 70,000. Remaining 900 customers are giving 30,000 rupees as a revenue. So in that case, what you prioritize? More than the majority is given by the top 10 people. So prioritize these people first. Solve those people first. Give the discounts or privileges to these people first. Coming to the remaining 900 people, if you're not giving a proper care, if they wanted to leave, no problem. If they wanted to leave out of your business, no problem. Because 900 people together generating only 30,000. Only 100 people are generating 70,000. If you motivate these top people, they can only increase their budget. You can cover the 30,000 from these top 10 people. You get my point? So this is how the percentile and the deciles are going to help you to take a better decisions for tomorrow. Is this clear? See, you might think 90% is just a normal value. No, it will give you so much insights. Is this clear? How percentile is going to help you to take a decision? Yeah. People in online, is this clear about the percentiles? Yes. So same way, deciles, you know, decile means how much? Decile is a value which is used to divide the data into 10 equal parts, like 10, 20, 30, 40, 50, 60, 70, 80, 90. How can I find the decile? See, for example, I wanted to find the decile that to D2. That is D2. D2 means 20 percentage. So I need to go by finding this particular. That is, I find the decile. See, for example, 30, 40 value, which is used to divide the data into 10 equal parts, like 10, 20, 30, 40, 50, 60, 70, 80, 90. How can I find the decile? See, for example, I wanted to find the decile, that to D2. That is D2. D2 means 20 percentage. So I need to go by finding this particular DF. Here you need to specify 0.2. Here you need to specify 0.2. Let me go by writing, print me the value that you're getting. See, 80% of the people, top 80% of the people are going to spend around 539 rupees. You getting my point? See, out of 100%, we already got to know that top 10% of the people are spending 4,699. And out of that, remaining 80% of the people are spending around 539 rupees. Like that, you can go and find the percentiles and the deciles. Percentile once again. If people are clear how the percentile value will be used, simple guys. Whenever you calculate the percentile, for example, you are calculating about 90 percentile. Okay, so whenever you calculate percentile, for example, you are calculating about 90 percentile. 90 percentile means you got this particular value, right? Which indicates that when you say 90% means you're talking about top 10 people, top 10 customers. If you're calculating 80 percentile, which means you're talking about the top 20 customers. If you're calculating the percentile of 75, then you're talking about top 25% of the people. Did I mention remaining 10 people or top 10 people? The top 10 customers spends this value. If you people are not looking at the document properly, don't ask me the wrong questions. Okay. I'm already telling you this. Top 10% of the people will spend 4,699. Why we calculate the top people percentage? Because we can prioritize the customers as high priority customers, low priority customers. See, we know how to respect. Yes or no? So you go and give a respect to a beggar who is begging at the road. Sir, sit, have a drink, have a water. No, right? You give a respect to the person who deserves. Yes or no? So how do you know he deserves? See, when I came into the classroom, you people said me that good morning, sir. Why you're not saying good morning to the people standing out there? You prioritize, yes or no? Here also, I'll prioritize the top 10 people because they are the people generating most of the revenue. Okay, so to know who are those people, how much they are generating, then I'll go by decide this. Clear? So that's why I'm prioritizing. Is this clear? So that's what. See, deciles, I already mentioned, which is used to divide 10 equal groups. So that's what. See, the final business takeaway is descriptive statistics connects a raw data into a business understanding. See, whenever you see this particular data, it's a normal data that we have created around 22 values. These 22 values, how many statements that we have passed, how many insights we have given to the business person. So that is the specialty of descriptive statistics. That is the specialty of descriptive statistics. These will help you to see what is the normal, mean, median, mode. How stable is the revenue? Is the revenue increasing than the expected or decreasing than the expected? Given by standard deviation, variance, IQR, and to see who are the extreme customers, like VIP customers, that can be given by the skewness, kurtosis, and the percentiles. Is this clear? So this is about the descriptive statistics. With this, we have successfully completed end-to-end about the descriptive statistics. Is this clear? Of central tendency, done. Measures of dispersion, done. And I said we can do the analysis even by using the visualizations as well. Even by using the visualizations as well. Yes or no? So let's see what are the most frequent visualizations we use to get an insights out of the data. Okay. First, I'll explain you the theoretical part, what is each chart is about. Then we see the practical implementation. Is this clear? So that's what. See, even data visualization helps you to represent and communicate the data insights effectively. Yes or no? The various type of charts and plots are used to analyze the data patterns, trends, and the relationships. See, the primary chart that we are going to use is histogram. Histogram. How many of you have completed Matplotlib or Seaborn using Python? Data visualization? Only few. Okay, no worries. I'll explain you. See, first of all, when to use histogram. See, when you people are going to do the project life cycle has a one major step called EDA, exploratory data analysis. We will explore the data to get an insights out of it. The exploratory data analysis can be done through the visualizations or can be done by using pandas and even NumPy also. Most of the people will say EDA means Matplotlib and Seaborn. No. Even by using pandas, you're calculating group by. That is also EDA. So whenever you do the EDA, we are going to choose visualizations. In that, the exploratory data analysis can be done in three different ways. One is univariate analysis, bivariate analysis, multivariate analysis. Whenever you are going and analyzing only one variable individually, that is called univariate. When you are going and analyzing the relationship between two variables, then it is a bivariate analysis. When you are going to find the relationship between more than two variables, then it is a multivariate analysis. Clear? When you people are doing univariate analysis, a variable can be of categorical data, a variable can be of numerical data. Yes or no? When you wanted to do the univariate analysis, that univariate variable is a numerical column. Then we go by using histogram. Clear? When to use histogram? If you have a categorical column, you cannot construct a histogram on top of it. Histogram is specifically used to find the distribution of a single numerical column. Clear? It's a key point. Okay, that's what. See, purpose to show the distribution of a selected data set. That is, when data analysis can be done in three different ways. One is univariate analysis, bivariate analysis, multivariate analysis. Whenever you are going and analyzing only one variable individually, that is called univariate. When you are going and analyzing the relationship between two variables, then it is a bivariate analysis. When you are going to find the relationship between more than two variables, then it is a multivariate analysis. Clear? When you people are doing univariate analysis, a variable can be of categorical data, a variable can be of numerical data. Yes or no? When you wanted to do the univariate analysis, that univariate variable is a numerical column. Then we go by using histogram. Clear? When to use histogram? If you have a categorical column, you cannot construct a histogram on top of it. Histogram is specifically used to find the distribution of a single numerical column. Clear? It's a key point. Okay, that's what. See, purpose to show the distribution of a selected data set, that is numerical column. How the histogram will be constructed? See the description. Histogram is used to display the frequency distribution of a continuous variable. What I mean to say that frequency distribution. For example, I'm talking about age. For example, I'm talking about the distribution of age. Okay, let's say I have a customer age group from 0 to 100 age group. So when I do the histogram, what it will do means it will create bins. It will create a bins, means whatever the age column you have, it will create some groups. How? 0 to 20, one age group, 20 to 40, one age group, 40 to 60, one age group, 60 to 80, and 80 to 100. For example, let's say 0 to 10, next, sorry, 0 to 20, 20 to 40, next, 40 to 60, 60 to 80, and 80 to 100. Here, how it is creating the group, right? Like 0 to 20 age group. How many people are falling in that particular range will decide the height of this particular bin. You getting my point? In histogram, whenever you give a numerical column, it will divide the data into few bins or few groups, and then it will represent that group as a bar. The bar size will indicate the frequency of that particular group. Means how many people are falling in this particular age range. How many people are falling in this particular 20 to 40 age group. How many people are falling in this 40 to 60 age group. How many people are falling in this 60 to 80? How many people are falling from 80 to 100? This is the example of histogram. This is how histogram looks like. This is how histogram looks like. Clear? You might say that, sir, it's looking like a bar chart. No, it's not a bar chart. What is a bar chart? Whenever you do the bar chart looks like this. In the bar charts, the bars are not connected. In the bar chart, the bars are not connected. Like this, you'll get it. This is bar chart. This is a histogram. You get my point? So that's what. A histogram is used to display the frequency distribution of a continuous variable. It divides the data into bins and shows, see, it divides the data into bins and shows how many data points are falling within the each bin. If the values are high, longer bin. If values are very less, a shorter bin, you can see it. Clear? Example. For example, you wanted to see the ages, customer ages, which could be divided into the bins like 20 to 30, 30 to 40, 40 to 50. And whenever you draw this particular histogram, you have the flexibility to choose the number of bins that you wanted to decide. You want 5 bins, then 0 to 20, 20 to 40, 40 to 60. You want 10 bins, then 0 to 10, 10 to 20, 20 to 30. You have to decide. I'll show you when we are going to do the programming itself. Clear? So that's what. See, whenever you do this, the histogram looks like this. The histogram looks clear. So that's what. Then 0 to 10, 10 to whenever you do this, the histogram looks like this. The histogram looks like this. Is it clear? And see, the key points to remember when you people are working with the histogram is This will help you to understand the distribution and spread of your data. And be careful, too many bins may lead to the overfitting. Too few bins also maybe lead to the oversimplify. Don't go by very few bins like 2, 3. Don't go by more bins like 20, 40. Okay, select a appropriate number like from 5 to 10. 5 to 10, this is more than enough. Okay, don't go less than 5, don't go more than 10. Then it will be a confusion for you. You cannot get a proper conclusions out of it. Yes or no? That's what. Even in this also, guys, for example, if I'm giving a project, okay, let's say you have 50 students, 10 students, I created 5 groups. Okay, if I create 2 people as a 50 groups, no consistency. Yes or no? So that's what here I'm telling. Clear? What is histogram? How it looks like? What it will do? Practical, we'll see. Okay. See, guys, imagine you people are already hired as a data scientist for a e-commerce company like Amazon or Flipkart or Zepto, Zomato, whatever it is. So the leadership team is asking you people, we have a tons of sales data. We have a lot of data, but what it is trying to tell us, I'm not able to understand. So you help me. So your job is to turn the data into decisions by using the visualization. Clear? So step 1, we need to create a sample data. We need to create a sample data. How I'm going to create a sample data? You people have an idea of NumPy? NumPy. Okay. I'm going to use NumPy to generate a synthetic data, which is looks like a real, but it's a dummy data. Which looks like a real, but a dummy data. Yeah, who don't know the NumPy? No worries, I'll explain each and every function very clearly. You can understand. Clear? First of all, I'm importing pandas and I'm importing NumPy as a libraries. Next, I'm setting up. See, guys, you know packages, modules. So there is a library or there is a package called NumPy. In that library, we have a module called random. This random is specifically used to generate a random numbers. Okay, which will generate a random numbers. Getting my point? What is this seed? Seed is equals to 42. Means, in general, how we know, whenever I use np.random.rand, whenever I run, every time it will generate a new number. Yes or no? But when I set random seed 42, you generate every time the same number comes every time. Okay, whenever you execute the same code again and again, every time you get the same output. Okay, because see, whenever I'm testing the code, like this is the visualization, this is the insights I got. Same data I shared with you people. You went to home, you people are open, you executed, you got some other output. Array sir said something, I'm getting something. You get a confusion. So to avoid that, I'm fixing the random value generation. Clear? So this is what this random seed will do. Clear? Next, n is equals to 5000 means I wanted to generate 5000 records. I wanted to generate 5000 records. Let's see, I'm creating a data frame. pd.dataframe. In the data frame, I wanted to have a column called order ID. Order ID is equals to np.arrange 1, n plus 1, which means from the NumPy, there is a function called arrange, which will generate a numbers from the given range 1 to 5001. Means it will generate 1, 2, 3, 4, 5, 6, 7, 8 till n minus 1. Sorry, till here how much? 5001. N plus 1 I said. So 5001 means it will generate up to 5000. It will generate up to 5000. So how many order IDs you have? 1 to 5000. Done. Next, customer age. Customer age. See, NP in NumPy, there is a module called random. In that, there is a function called randint. Means generate a random integer numbers in a given range of 18 age group to 65. How many values you wanted to generate? 5000. N means 5000. Clear? Customer age, I have a column. We have a 5000 records ranging from 18 years to 65 years. Clear? Next, gender. I'm using np.random.choice. Means randomly select male or female. How many times you have to select like this? 5000 times. You got gender column also. You got gender column also. You people must and should know generating the synthetic data. Because when you people are working with some critical companies, they will never share you the data. They'll give you the structure. What are the columns you have? What type of data that you're going to have? So you only have to generate the data to test your code. Be careful. And city, randomly select any city out of this. Product category, same, select any category out of this. And price, randomly generate the price from 200 to 20,000. How many times? 5000 times. Discount percentage, same, random integer from 5 to 40%. Rating, see, np.random.uniform means uniform means it will follow the sequence. Sequentially, I wanted to generate. So then, see, whenever I create this particular data, so when I do this, let me go and check the data. See, this is the data that I have, guys. Order ID, customer age, gender, city, product category, price, discount, and rating. Along with that, I wanted to add a final price after the discount. How can I add a final price into 1 minus the discount percentage? When I do like this, I get the final price. After creating a final price, I wanted to add the delivery days. How many days it is taking to deliver a product? So the delivery days from 1 to 10, like 1000. Now it's a perfect data set. It's ready to use. See, actual price is 4674. After giving 35% of the discount, the final price is 3038 rupees. Clear? Now let's go by histogram. By using histogram, what business question that you are going to address is, are most of the customers pricing small orders or big ones? I wanted to see, is majority of the people giving higher orders, high price orders or low price orders? Okay. So to do that, to do the visualizations in Python, we have a specific library called matplotlib. You get my point? Matplotlib. In the matplotlib, you have a module called pyplot. In this, you have all the modules. I mean, all the charts, all the customizations like adding a title, removing a title, adding a color, background color, everything is available in PyPlot. So we are going to import matplotlib.pyplot as PLT. Okay. After that, in the matplotlib, to draw the histogram, you have a function called hist. You have a function called hist. So plt.hist, the histogram function will take one column as an input, one column or a series. So how you are passing a series? A single column in a data frame is nothing but a series. So data of final price. I'm telling the program to divide the bins into 40 bins. Sir, you only said select the less number of bins. But here I have a large amount of data. So that's why I'm deciding this. But usually we don't go by much. Okay. Yeah. Next, x-axis order value, y-axis number of orders. Yes or no? Let me go and do this. See, when I do like this, so what you see, majority of the people are giving from 0 to 1000. After coming to the order value, let's say 12,500, 15,000 and 17,000. Coming from 12,500 onwards, still slowly the frequency is decreasing. Slowly. But look at this. Frequency of the people giving the orders from 20 to 2,500 is very huge. And the people giving the order value within a range of 5,000 to 10,000 is very high. 5,000 to 10,000 is very high. Yes or no? So from this, what is the business story? What is the insight you can communicate is most of the customers spend low to medium. Most of your customers are spending low to medium only. So only few customers are spending very high. So what type of decision that you can take? See, the first 2 points is your understanding out of the visualization. From that, you wanted to give a decision to the business person. How? First decision, launch a premium membership for high spenders. Premium membership means one day you will get the delivery. Prime subscription. What is the prime subscription? You're paying some amount extra so that you receive a product within 1 day of order. Same way for premium. You have a problem, within 1 day your product will be replaced even. Within 1 day, you have complaint, within 24 hours your issue will be resolved. If not, complete refund. Like that you can launch a premium policies. So you can generate more revenue, and to buy the premium, they'll pay some more amount like a subscription fee. So either way you're generating the revenue. Yes or no? So that's one. You see Hyderabad, Nilofer Cave. You have so many Nilofer caves. There is a same Nilofer cave, same chai, 500 rupees. There is same Nilofer cave, same chai, 50 rupees. What makes the changes? Ambience. Ambience. People going for 500 will get a complete piece. Neat ambience, full lighting and everything. Coming to 50 rupees, you have to take the cup by your own. You have to eat on the standing somewhere else. That is the only difference. That's what. Next, focus marketing on the mid-range products. You need to focus marketing on the mid-range because majority of the people are buying that low-end products only. So that's one. Have you ever seen that Amazon, Flipkart giving you the messages or ads like you get a product for only simple 80,000 for simple 1 lakh. The price is very cheap, 1,29,000. No, you always see you get a items worth of 999, flash deal 299, great Indian sale, everything for 599. Why? Because they wanted to target the mid-range people. They wanted to target mid-range people. That is what. Clear? So this is about the histogram. How you are going to do this? How you are going to communicate the insights out of it? Is this clear? Everybody? So next, we have a bar plot. Next, we have a bar plot. First of all, we see why we use, when to use. Bar plot is specifically used